Okay. All right. Hey guys. Yes, I'm asking questions. Sorry, my video crash. I keep too many things open. Anyway, so let's start. Yeah, perfect. Okay, great. Thank you to join. I had to restart. We had several people joining, but I will go ahead. It will be recorded, but it's nice to have people interacting. So I want to cover briefly two topics today. Briefly for me, but be ready for the next 3 hours. Um, anyway, and yeah, okay. And it seems that Bruno is here. See, let me answer him, okay? Because he was supposed to be. Uh, how do we do it? I don't know. Zoom. What is the best way to join somebody? Never done this before. Uh, we want to do this on a regular basis. Maybe every weekend around this time. Yeah, Randall. We are going to keep it short, like maybe 2.5 hours or something. Um, very very short. But I was trying to. I'm trying to have also my friend. Hi Matthew. Join me, Bruno. We had already a nice interview together. He's Italian American, um, and but I don't know how to do it. I don't know if it is Zoom. Also, my son is here, Saverio, and sometime we will do this together with him too. He's the more rational part of me, more Estonian-like. Estonian and Italians are like extremes. But if you give me a minute, I want to try to see. Maybe we should test this another time with Bruno, because otherwise it will take forever and we will just bother you. We will test that another time. So let's focus on what matters. So I was saying before I got cut. Yeah, just let me get a second. I will take the questions. Uh, First, let me start with these, and then we go with questions. Okay. So the entire idea about what I'm doing here is that, and I was saying, eventually I want the data being available to people. So we will try to see if we can put them online or whatever. So everybody can do this analysis. You don't have to trust me. You can do it in a different way. Maybe we can learn. But the entire point is, who cares what Giovanni thinks? Who cares what Plan B thinks? Who cares about what anybody thinks, right? Let's look at the data. Let's what the data tell us, and then let's learn. Because in the end, reality trumps everything, right? And Bitcoin does whatever Bitcoin wants, and we need only to learn from Bitcoin. And when I say Bitcoin, it's not that Bitcoin is alive. I mean, I'm kind of saying that it's alive, but it's basically the collective behavior of all of us, right? It's like expressing this higher than us entity that has its own rules, has its own way of behaving. And it's amazing because it does all these very intelligent things. This is the nature of my message. That is not a stupid thing. It's behaving in a very regular fashion. It's behaving with all these properties that are common to living beings, cities, organisms, and it's showing intelligence. So if we study and we learn from Bitcoin, not just the general principle, but also his behavior and this mathematical pattern, then maybe we can learn something too. and we should not try to impose, and of course that includes me, impose our own views. But if a data tell us something, and our interpretation is correct, because of course in the end is always a question of interpretation, but an interpretation that is not hand waving, is based on reality, right? Then doesn't matter what we think, we should accept it. Okay, so for example, I am against this idea of scarcity, but if scarcity was something that I saw in the data, that like by reducing, for example, issuance, right? Issuance is this idea of how many coins are produced per unit time. So in this case, I'm looking at every day, how many coins are produced every day. If this production of coins every day was reduced by 2, right, because of the halving, and then we see a spike in the price, or we see that sometime later this is done, the price goes up, then that is a reality, and as a scientist, that is what you're trained as a scientist, you accept it. You just simply accept it, and then you have to change your understanding of things. But if a data tell us something else, then we have to accept that too. So what the data is telling us, right? Because it's a very important thing to understand is we are at the halving coming. It's a big event. Everybody's excited. And I hear some of my friends, like Fred Krueger, for example, he's completely dismissing the bubble. And Fred is an amazing guy. I'm very thankful for him, because he's like a power law paladin. He's fighting, and it's nice because if I say something, okay, you listen and say that, but then there is another guy that, he has been a quant in Wall Street. He made a lot of money, so he's proving himself, because that is the beauty of the markets. You cannot bullshit around. With the markets, you cannot bullshit around. If you're good, you make money. If you're not, you don't make money. And yes, luck plays a role, but not that much, because you can lose and gain at the same time. People that are consistent with making gains when they are trying to study the markets is because they have some understanding of how the market works. This is why, for example, today I posted this video about one of the most successful, maybe actually the most successful investment firm of the world, that is by this mathematician called Simons. He's also did work in physics, and basically they call it like that a company is kind of like a physics department, physics and math department. They don't hire finance people at all, like zero. Like if you have finance, it's actually, they say, okay, thank you, we're not interested. It's all physics and mathematicians. And there is a reason, because our understanding, our tools allow us to understand better what is going on. And they have been successful, like 60%. There was a time, several years in a row, where they had 60%. That is crazy. It's completely crazy for any type of investment. And they don't manage like small little funds. They manage billions of dollars. Okay. So, and this is what I'm trying to share with you, right? This is the idea that we can use our way of thinking about physics, and analyzing the data, so we can learn from Bitcoin. Okay. So let's focus on what they did exactly. What I did, because I want to resolve this issue once and forever. Are these halvings, the question that we are trying to answer is, are the halvings that basically what really happens with the halving, right? The main important thing is that all of a sudden, the number of Bitcoin that are produced by this activity of mining, it's reduced by a factor of 2. Right? It happens in one single block. And all of a sudden, that reward is cut by 2. And of course, these rewards is never constant, right? It changes because according to how much hash rate there is, and if I say something wrong, please correct me, because I'm trying to understand these things myself, and I think I got it. But if I say something that is technical and is not completely correct, you can correct me in the chat. But my understanding of this is that according to how much hash rate there is, and that is variable, right? Because people bring in new machine, sometimes even a single company, sometimes they go with the grid that, there are hours when the electricity is more expensive, less expensive, or maybe they buy a new machine or new firms are coming in. And so this hash rate is not constant, right? It changes in time. And that changes the time it takes to mine a block. Then, once in a while, there is like an update from the difficulty adjustment that says, it took too little time in the last 2 weeks. They do it on a consistent basis, right? I think it's 2 weeks every time there is a check, right? We look at the average time that it took to mine these blocks, and if it is too short relatively to the target, that is 10 minutes, then the difficulty to mine that block, it goes up. The algorithm established that now you need more mining power. And so it's almost like a thermostat. It's trying to bring everything to equilibrium. This time to mine a block it cannot go too low, it cannot go too high, and it tries to stay within. But, because like a thermostat, right, it doesn't act immediately. Sometimes there are oscillations, right, of this value. And so that's what happens. And of course, if it takes less time to mine, if you look at how many coins are mined in a day, that will depend on this variable amount of time. And so this is why in this graph, you see these dots, okay? And so what these dots represents, every dot, and sorry, I'm trying to improve my graphs. People don't like this scientific notation. It's very useful also because we're talking about scales here. When you go in a big range like this, it's nice to have this scientific notation. It's not difficult. It's not that I don't want to change it. I can, and there are ways of doing that. It's just I'd rather people learn something like, 10 to the 2 is 100, 10 to the 3 is 1,000, 10 to the 4 is 10,000. It's not difficult, right? And so in the y-axis, in this graph that you see in the screen, there is the price of Bitcoin. And in the x-axis, there is how many coins per day are issued, okay, are being produced. And every dot represents a day, since basically the 2010 or something. We have the coins from the beginning, but price, we need that, the first exchanges to know the price of that Bitcoin was traded. Some people use electricity and other things like that for early transactions. And there's a decent way of doing it, but I'd rather look at the market prices. So it's basically since 2010, these are the days. Every single dot that you see on the screen, it's one single day. And then, so let's interpret. So forget for the moment the red line. Okay, pretend it's not there, and I will explain you later what that red line means. What you're seeing here is 4 clusters, right? Everybody sees these 4 clusters. Why do we have 4 clusters? Well, because we had basically pre-halvings, right? So the data on the right, on your extreme right, notice these are relatively big numbers, right? So this is when we were producing a lot of coins in the beginning, right? And then we had the first halving, the second halving, the third halving, and soon we will have a fourth halving, right? So every cluster represents before halving and after halving, first halving, second, and third one, right? So, and why they look like cluster? Well, because every time there is one of these cutting in half of the total amount of Bitcoin, because it's an average value, right? Like you see, it's varying here, but it's cut by half. There is a jump. There is a jump so there is a jump in the X. So it's moving. This cluster is moving to the left because it's becoming smaller by a factor of 2, but it's also jumping up. Why is jumping up? Well, because price, if I move to the left, it's not. I'm writing a Medium article, and I will post it soon on my X. So I'm trying really to explain it step by step in the Medium article. But the best analogy that I can think is this: it's almost like if you are in a chessboard, and you're thinking how all the pieces are moving. So if you have a rook, the rook can move horizontally, right? Because it's free to move upwards and sideways. But if you have a bishop, the bishop can only move diagonally. And here is almost like you have a bishop, because remember what we're plotting. We are plotting price on the y-axis, and we are plotting issuance of coins, it means productions of coins, on the x-axis. So the two go together. So if I move on the left, I need also to move upwards. Do you understand how it works? Because I need to say, well, what is the equivalent price for the particular value of x? And the value, it's there, so there is an average value for the price that is kind of the center of that cluster, and I need to update my value too. And so what I'm trying to show here, and I hope is convincing, that this jump is an illusion. It's not that you cannot say that it's jumping because the halving is creating that jump. You are jumping simply because it's almost like a puzzle, right? You're putting this little tile where it needs to go, but it's not going there because the jump on the left of the the coins, the shift of the coins by a factor of 2 is creating anything. But it is not a causative thing. Okay, it's almost like you're saying, if you claim that, it's almost like you're saying that a rooster in the morning when he's doing his sound, whatever that is, I don't remember the term. Maybe you can help me. Whatever, crooking or whatever it is called. In Italian, we call kikiriki. The kikiriki of a rooster. When he does kikiriki, the sun comes up, and you say, "Oh, look at this!" The rooster crying. So when he's crowing, I like kikiriki in Italian. So the crowing kikiriki, he's making the sun go up. It would be absurd, right, if you say something like that. Or even better, you see two things that are happening at the same time. The farmer, like you have a neighbor farmer, you see him waking up, together with the sun, because most farmers do that, and the rooster does the crowing, and you think the crowing, and you say, "Hey, look at this! It's very powerful rooster. It's making the sun go up and the farmer wake up. I mean, it's incredible." But it's neither of them, right? It's the sun and the two other things, that is the farmer and the rooster, are synchronized with the sun, because this is what makes them do whatever they do. So it's an illusion. It's an incredible illusion, because basically, and the red line is going to help us. And here, this is what happens to every cluster. And again, so there are two things that we need to understand. Why there are these jumps and why there are the clusters. And the other thing that we need to understand is why they are dispersed, right? They are dispersed, they are spread in each cluster, and we have already explained that, right? Because there is a change in issuance, right? So if you focus on each cluster, you are shifting back and forth, right, around some kind of an average value, and that has to do with this block, the block reward being variable. It depends on the hash rate, but because of the difficulty adjustment, these ranges are kept within a certain value, right? Because if they go too much on the right, that means too much coins produced. The difficulty adjustment brings it back. If they go too much on the left, they get back too. So it's kind of like thermostat. So if you look at the temperature of a room, it's never going to be 100% stable. You're going to see some oscillations because the thermostat needs to act, it needs to cool down the air, or warm it up, or whatever, if you want to keep a certain temperature, and you will see oscillations. So this is why we see this variation. And every time we oscillate in the x-axis, there will be also change in price, right? Because the price is changing during between the halving. So every cluster represents the behavior of Bitcoin, both in terms of how many coins are produced and the price within within the time between the halvings. And then there is a sudden change, and what happens, the cluster shifts on the left. That means on the left, we have less and less coin. So basically, if you're thinking about time, the time with less coin is closer to the present. So this last cluster on the left, it's present. And you say, why did he do it in that way? Well, it's simply because when you plot it. You could do it in a different way, but it's easier to plot small number on the left and bigger numbers on the right. So basically, we are going kind of from the right to the left. Right represent old times, right? In fact, all the way to before the first halving happened. Then there was a first halving. As I go towards the left, the second and the third one, right? So this is all what this cluster represents. And there is variability because of the variable rush rate. And the price was changing. But you see, what we can observe, the first thing that we can observe, there is not really a pattern in each cluster, right? It's random. Maybe there was a slight pattern that actually I pointed out, we will see other graphs, where they kind of tend a little bit to go towards the left in the pre-halving. And my interpretation of that, and we will see other graphs that I think reinforce the interpretation, is that yes, when before the first halving, when the price was few dollars, because you can see what the price here is, right? So if you go how to read these graphs is important, because it's one of the things that we want to learn, how to understand these graphs. So always look at your X and Y. So what the Y say when we were aware that the price was like a very, very small, like I see. One thing I can do to help, I'm going to, when I produce this graph, I'm going to make the labels bigger, the numbers bigger. I can do for sure that, so you can see them better. But you can see here, right, if you squint your eyes a little bit, that we're talking about few cents, 10 to the 0. Anytime you take the power of 0 something, doesn't matter what the number is always 1, right? So we're talking about $1 and at most $10, right? So that sounds right. That was before the first halving. So they are very small prices. There was no many coins in circulation yet. So a change even within this cluster of issuance, in particular, notice as the issuance became smaller, right? Because if you go to the left, the issuance became smaller, the price kind of follow, right? It kind of makes sense. It kind of makes sense because if if I had a less coin produced, maybe there was more demand, there was a less coin floating in the market. But this is when there were not many coins available, and it was a small effect anyway, very small effect. But there is a little bit of tendency. See, this is actually help us, because if it was this kind of effect, if this effect that means reduction in production makes the price change, we will see these happening all over the place, not just in the beginning. So actually, many people ask me how the data will look like if it was actually a relationship in this. Something like this, but even stronger. So we will have see the data kind of slanted towards the left, because in that case will mean less production, higher price. Do you see? Do you see this? You understand that? See, this is how you learn to interpret the data. You learn to be a scientist. You learn to learn from the charts. These charts tell a lot of information. So, see, a little stories coming up together. It looked like in the beginning, this is even before halving, within this cluster, there was some effect of that kind, where the less coins were produced in that particular day, kind of push the price a little bit up. And again, if this interpretation doesn't make sense to you, ask me a question or oh yeah. Thank you. It's a very good suggestion. Yes. Okay. Yeah. Somebody's telling me put it in a presentation. I always forget about that. From Corinth. All right. I don't see the screen. That is part of the problem. I don't see your questions, but I can't, because it becomes bigger also in my screen. But for now, hopefully you can follow me, and then I will get out of the presentation mode to answer your questions. Okay. And I wish there was a way for people to talk so I could hear your voice, but it's no Discord. You can do that in Discord, but not on YouTube. But anyway, so you see, that is my interpretation of that. And we have other graphs where it kind of shows that, right? It kind of show that it's true that there was a little bit of an effect. But in the other slides that I have, I kind of measure it in percentage. It's like less than 10% effect. And it didn't have anything to do with halving, because actually it was before halving. So it's it's cool. It's a way of saying, yeah, it had an effect early on, but now because think about it, it's also the logic, right? When we interpret the data, we want to look at the data, but we also want to understand the logic, right? So when I was teaching physics and math to my students, I was always saying this, which I think is very useful to understand how we think in science. I said it's almost like your way of analyzing things, your way to reason things through science has two legs. So first, use your intuition. And many times when we start to think about things like data and science and physics, we are not used to think about these things because, our brains are made in such a way that we react quickly to things, right? We don't have time to, I have like tiger coming towards me. I don't have time to think, okay, what is the acceleration due, to this mass of a stone that I want to throw against the tiger, and how much force. Okay. You can do that when you're in the cave and you're safe. You can start to, if you have a math and the knowledge, you can start to come up with a trap, with something complicated. But you have to survive first the tiger going against you. So you throw a stone or you run away. So our brain are not made like that. If we don't use, like, it's basically like a martial art, right? We do martial art, you learn to do certain things in a certain way, even if they're not natural, right? To give a feast in a certain way, to put your body in a certain way, and it takes time, a discipline. It's the same thing with science. So there are these two legs, right? One leg is your intuition. So you start with intuition, you kind of start to interpret the data, and then you start to use math, like this graph or some calculation, whatever, because this graph is kind of visual math in a sense, right? And then whatever information, whatever data, whatever logic you can use, and then that gives you a little bit more intuition, because it's not all of a sudden, right? You start to learn something, maybe even questioning your first assumptions. And then once you build some intuition there, you go back, to the normal intuition. You're starting to interpret, you're starting to ask a new question, you're starting to make sense of what you just saw. And then you go back to the math and you do this back and forth, back and forth, back and forth, until you learn more and more, and sometimes it takes years. It's like a spiral. Right? Like the Bitcoin is a spiral, learning is also a spiral, right? So you go bigger and bigger and bigger. So I did like this, but it's actually like this, like Bitcoin, it becomes bigger and bigger. So you're including more and more information, more understanding. And even for an expert, like there are times where I'm thinking about stuff that I learned years and years ago, and now I understand what it means and why it should be applied. This is how it works, right? So see, if I go to the next cluster, look, it's just a blob, and it's same. It's just blobs. So there is no relationship between issuance and price. Like here, if you want to see the second one, it's almost like it's also actually producing more coins. Remember, every time you go to the left means producing more coin. Every time, going to the left is producing more coins. Going to the right means producing. Okay, let me restart. Going to the right means producing more coins. Going to the left, producing less coins, right? And if you look, it's kind of, I think, random. But if anything, the second cluster has a little bit tendency for the price to go up when actually you're going to the right. That probably is a fluke, or maybe who knows what else was going on, right? So there is no really logic there. Why it should be like that? It's probably something independent that made this. But in general, you look at that, it looks basically random. All of them look random, right? And so the first question that we should ask is, forget about the jumps, right? Why it should behave in a different way, right? This relationship between price and number of coin produced when we are between the halvings. If this idea that reducing the number of coins creates these supply shocks, or the market is less flooded with coins, etc., it should work anytime. It should not just work when there is like this big jump. Also, because remember, this big jump happens just once, happens at one single block. And so it's kind of ridiculous, right? And you will think, well, it happens in one block, and we will analyze that question, right? Because some people can say, Well, okay, yes, it happened one block, but it's not felt by the market until a few months later, because this is what, for example, Plan B will tell you, right? Because there is always a delay before you see the price going crazy. And his interpretation is the market needs time to respond. I don't think so, because sure, the market responds, but it doesn't respond to this change in issuance, because there is no relationship with that. Now, yes, there is something happening that is associated with this halving, but in general, there is no this relationship, because if this was true, if this jump was true, I don't, and anybody can write an answer to that, right? So my question will be, why doesn't work between halvings? Because even by little, and these are not little. Look at how big these changes are, right? If you look at the shift between the maximum shift for each cluster, I will say that is as big, almost, right, as the shift that is required to go to the next level. So within a cluster, you have shifts in issuance that are more than 2 times. And I can show you in the other graph, there are more than 2 times. So if there are these changes, if there are not two, we can look it up in the other graph. I plot it as a percentage. If they are not as big as a 50% reduction in issuance, what happened during the class, are very close. So why we not see an effect there? There is no logic about that. Why the market should care only after the halving and not within the halvings? You see, this is how a scientist will think. So why don't I see that? If it was a true effect, it should be there all the time. So these dots should not be like a blob. It should be like shifted. They should be slanted. That means if I go to the left, I should see, that means a reduction in production. I should see an increase in price. It should have this kind of a slope. Does it make sense? Does it make sense? I please tell me yes, no. I don't understand anything. Move more your hands, because maybe we understand you better if you move your hands. Write anything you like. But to me, it seems complete, absolute, unbreakable logic. So you already see there is some huge problem with this assertion, right? And the other thing is, the other part is that I told you that this strange correlation that we see, this trend that we see, is nothing else than an illusion. It's simply because I need to adjust every time I shift on the left. I need to adjust where the price is, right? And if it was a general trend, yes, it will be also expected, and maybe there be actually a very big jump in price itself, but it doesn't happen. So this is why I made this red line. So what is the interpretation of a red line? Basically, in this case, I did because I don't have time on my x-axis, right? I have issuance. So I did this transformation and say, okay, how much issuance there was, after 10 days? How much issuance there was, like the average, right? How much issuance there was after this and this? So basically, I transform issuance in time in a certain sense, right? And then I have this equation that tells me where because basically I use the power law, right? I use the power law because the power law is kind of a general trend that it's a good approximation at a minimum, even if you don't believe in the power law, or where the price of Bitcoin was at that particular time, right? And it's because this is the famous log chart that I mention all the time. We have the log of price on the y-axis, the log of issuance on the right axis. The power law will look like a straight line. And so it's not a straight line. Like remember, it's this t to the 6. So in a linear graph, we look like very, very fast parabola. But one day, maybe I'll show you the math, why a fast parabola looks like a straight line in this graph. It's a very simple thing, but we can go through the math another time. But it looks like a straight line. And why it goes from the right to the left? Well, remember, time in this strange graph is actually going from the right to the left, because we have less issuance towards the left, right? It's a convention. It doesn't have to be all the time, going to the right for time to be bigger, right? You can have reverse time. It doesn't matter. Once I tell you what is the convention, maybe it's not It's like a clock. Like some when I do the clock, I had to redo it, and it's okay. I understand because a clock, you want to be consistent, you want to be clockwise, but it doesn't matter. It's a convention if it goes clockwise or anti-clockwise. But in this case, I wanted to do it in this way because it's easier to plot this issuance number as something that grows instead of decreasing. But that time will go to the left, right? So this is why you see this graph coming up. So in theory, this red line doesn't know anything about these jumps. There is nowhere jumps because I took kind of an average value of issuance, and then I wanted to see the equivalent time associated with that, and then I was able to plot this line. So this line has no knowledge of the issuance, underlying issuance, and it's just simply showing how price will look like if it is driven by something else, like time, basically. And we know that it's not really time. We already demonstrated in our theory there are two things that drive the price. One is, I don't know if you read the theory. If you didn't, please do it. If you don't want to read the theory, at least watch the videos. My son spent a lot of time and energy making this nice video, so please watch it. It's also in the channel. It's actually pinned to the channel. And the theory tells us there are two things that drive the price. One is adoption, and the adoption is a function of time to the cube. And there are reasons because of that, because it looks like a virus. It's a virus where there is some kind of curbing mechanism. And, there are many curbing mechanisms in Bitcoin. We can discuss that later. Like it takes time. You have to be orange peel. And it's good. It's good because we want people being informed. Memes spread exponentially, right? But something that requires attention, something that requires decision making, there are dozens and dozens of papers that shows that instead of being an S curve, that is the typical curve of adoption, that initially is exponential, it's something that looks like a power law. And many of them, in fact, are the power of 3 for whatever reason. And Bitcoin is exactly like that, okay? COVID was like that. I know you hate COVID, sure. We're not trying to say Bitcoin is like COVID. It's like one of these things that spread, but instead of being a bad virus, it's a good virus. It's really cool. And the other thing that happens in terms of creating this line that you're seeing, this red line, is the other mechanism, because in physics, we are all for mechanisms. We want to understand how something causes something else. That is what physics does. We want to find quote unquote laws. And people confuse this idea of laws. I'm not saying that it's like gravity. Laws means in science and in physics means something, a regularity, a pattern. It's another, we use this it's like when you deal with law, they have all this terminology, right? And many people sometimes get confused, but lawyers are very precise in how they use their language, okay? And physicists even more, much more, because what we're dealing with is precise. And human behavior, when you collect human behavior, can be very precise. It's less precise when the gravity or other natural laws, but we are part of nature. And think about ants. Ants, you can study ants and they behave in a very specific way. Same thing with human beings. Okay, individually maybe we are more free, but when we work as a group, we're not. We follow very precise rules because then it's all about efficiency. It's about making things. If there is another way of doing things and it's not efficient, it's going to go down, right? So probably this spreading of a various T cube is the most efficient in this moment to spread this information about Bitcoin that we can have. This is why we get it. Then the second mechanism is this thing that this scientist discovered called the Metcalfe law. The Metcalfe law says if you have a network, and Bitcoin is a network, then the number of connections are very important in this network. And in fact, the number of connections is what gives value to the network. The more connections you have, and connection will be, how many people you know. There is sometimes you have these big nodes, very important nodes that are maybe like a YouTuber that makes video about Bitcoin, some big leader, like leader, we don't like leader, but thought leaders, like like spiritual leader in a sense, right? Like Taylor, they tell us it's inspiring us, etc. he is a super node. He has a many connection, more connection. He reaches millions of people versus, you that have maybe 10 friends. So there are different type of networks. It depends how well every node is connected. But in theory, the theoretical result is if everybody was connected with everybody else, the value of a network will be to the square. And so when you combine these two things, because with the powers, right? So it will be B corners equal T cube, and then you take a parenthesis to the square, right? Because that is when we calve. And how it works with powers is that you don't sum them, you multiply them. So you have 3, right? T to the cube due to the spread, then square because of Metcalfe law. So, this imaginary parenthesis, visualize it in your head. 3 times 2, 6. This curve that you see here is T to the 6. Okay? So this is a straight line that is not really a straight line, it's a curve, but it looks like a straight line in a log graph. It's T to the 6. And it does its own thing. It doesn't know anything about issuance. And you can see what happens, right? When I shift. So first of all, notice what happened. It continues to go. In fact, it continues to go in very precise manner within the cluster. So that shows you it's completely independent from what the issuance is doing. It's doing its own thing. And then in between, it continues to do its thing. So when I shift my cluster because of the reduction in production, the cluster is going to move where the average value of that straight line is going to be. And it's going to do exactly that. And not because it's creating that change. That red line does its own thing, simply because, of course, if I'm plotting price versus issuance, where you want to put it, it cannot be anywhere else. It needs to be there. It doesn't mean that it's creating this change. Not at all. Because if it was, so this is a bad case of correlation doesn't mean causation. There are times when it means if you have a real mechanism that creates that correlation, and that is what we do in physics. We are expert in trying to look for causation when we see correlation. So it may be the exception. In physics, it's not, because almost everything we study is due to something, but you have to be careful. That saying that people repeat all the time, it's basically like a warning that we teach the students, be careful, because there are many times where this is not true. It's an illusion. This is that case. This is the best possible case, because it's so stupid. All what happens is not even some complicated behavior in time that maybe you still need to understand, and maybe you have to separate and do something complicated mathematically. It's just logic. It's pure, simple logic. And there have been people, some stat people and some math people, they wrote several articles against S2F, because basically I didn't want to mention S2F because everybody gets mad when I mention it, but basically this is what S2F is based on, because he's kind of doing this. He does it with two things. One is the issuance, and the other one is the supply. That is even worse, okay? So I didn't want to mess up with something complicated like S2F. I wanted just to focus on issuance and show you that there is a problem with issuance. That is really the only thing that changes when you calculate S2F, because the supply is almost all there, already, kind of. But with supply is even worse, because supply actually grows. So he kind of wants it in two different ways, right? He wants to increase the price when issuance goes down, and he wants to increase the price when supplies goes up. That is completely nonsense, but we can discuss that another time. I wanted to focus only on issuance, because many times when you try to do something scientific, you break it in pieces. And you can see that issuance has nothing to do, nothing. And it's so silly, simple behavior in time that is only jumping, right, by a factor of 2, that there is not really necessary need to do anything statistically difficult. And people have done it to show that S2F doesn't work, but they miss the communication with the average person, because the average person doesn't understand this co-integration stuff or this out-correlation, all these things that these stat people use to convince us that this doesn't work. But I don't know if they even understand it themselves, the intuition behind. And this is what physicists do. We try to break things apart, we do the small little components, and we try to build intuition. And this is what I notice in many of these economists, many of these stat people. They don't work like that. We are maybe different type of people, maybe different training, but they don't work like that. Physicists do. We want really, really, really understand what is going on with the data. And then later, and you see, this actually gives us some freedom, because many times we go there, we do lines, we do all crazy things. We take a lot of time. Do you understand? Like we wrote, me and H.C. Berger wrote this article about this. I think he's a PhD student. He's actually hired by a firm, by an investment firm. And they should have hired the physics. I mean, I don't want to be mean to the guy. I don't want to be, okay? Because he can study physics. Go and start get some classes in physics and update your knowledge. But I will not mention his name, nothing. I'm not going to make fun of him. But he told, he was so angry against our model because H.C. Berger made it popular, right? So this was actually more or less during the time when SWF came out. And H.C. Berger said, look, there is this other model that this guy, Giovanni, he knew me just as Iconophist 1. This was my Reddit handle, Econo, right? Economics, physicist, because there is an entire branch of physics that studies economy, econophysics. So my name was Econophysicist 1. No, I am the only one. But anyway, just kidding. But so he looked at my post that was in 2018 about the power law. So, we have already, I don't know if many people know, we have already 5 years of predictions. So this is what's so funny when people say, oh, you didn't predict anything. Yeah, I'm predicting stuff since 5 years ago. Maybe it's you that needs to be updated. Me and H.C. Berger, we all the time say, yes, this beautiful graph where it shows, this is what I will look 5 years ago. This is how it looks now. It's exactly the exact thing. We were right in average, right? Over the long term. As a mean, right? This is what we mean. And so, he was telling people about this model. Many people associated him being the author, but he quoted me, right? And this is how he started. In fact, if you see, there was this German interview where he tells the story, and he says that he saw this graph and I thought that I made a mistake, that I was some stupid. He wanted almost like being angry with me because he didn't understand what was happening with this graph where you see the price of Bitcoin, because everybody sees it curving, right? And so he saw this straight price like this, and he was kind of like, what is going on? What am I looking at? And then he realized that I was taking the log of time. But he's not stupid, so he understand. Okay, this is what is going on. And then he saw my name, econophysicist. Probably this guy knows what he's doing, if it's true that he's a physicist. And then he wanted to reproduce himself. And once he reproduced it, he was so convinced, and he thought this is the way to understand Bitcoin. That he actually started to write his Medium article and be kind of like basically somebody that was letting everybody know, right? An educator in this new way of understanding Bitcoin. And so, he was attacked by somebody that is supposed to be an economist, a PhD, probably young, relatively inexperienced person. And this guy was telling, we wrote an entire article about debunking the power law. And it's so absurd. The entire article is absurd. And one of the things that he says is, you don't take the log of time, like this. Well, it's absurd to take the log. It's crazy. Nobody ever does that. That is BS, complete BS. So, this how we, and you can read, we wrote an entire article debunking the debunkers. And it's complete nonsense. And, we have also an economist and other people that are supporting our approach. There is this professor, he's also a Bitcoiner, Seats, I think his name, something like that. And he came to my rescue when I had another battle with another guy like this that doesn't understand how physicists do things. See, what economists gave us, quantitative easing. It is what is my joke. The only thing that they got, and physicists gave us everything else, right? The telephone, the radio, the telescopes, almost every invention, there is a physicist behind. Okay, directly or indirectly. He discovered the science, and then the engineers applied it. or they discovered the radio was invented by physicists, Marconi, Hertz, and other things, all the other things, the engine, everything. So you do different things, to understand the data, and this taking the log allows us to discover these power laws, these very regular behaviors. And you see, in this case with Bitcoin, there is no relations. There is absolutely no relation between these two things. And if you're not convinced, this is what I did next. And hopefully you see this graph, right? You should be able to see this graph. And I will stop in a moment to allow you to ask questions. But let me show you this graph, okay? And then we can maybe have a discussion. So in this graph, what I did, because you could still have the doubt and say, no, I don't believe it. I think still somehow Bitcoin knows about this issuance and the price got affected later on. Can come up with some excuse in your head. And what I did here, I made up what I call the random coin. So people say, well, I don't see random coin listed. Or let me go back to slideshow. Okay. So random coin is a made-up coin. It doesn't exist, right? So don't go and buy it, please. Because some shit coiners for sure is going to make random coin next. So that doesn't exist, or maybe it does exist. There are so many shit coins. Maybe there is a random coin, but it's basically a made-up coin. So I kind of use the power law, but I change the exponent, so it could be 2.3 instead of being 6, right? Because this is what it is, right? Price equal t to the 6, proportional to t to the 6 for real Bitcoin. For this random coin, I randomized it. In fact, I have like a little video where I randomize both the single prices, for every day, but also the trend, this power. So it can be 3.2, 4.9, so anything you like, but still some kind of general trend. I could try a sine wave. I don't want you to make it too complicated. It doesn't matter. The entire idea is, if I have something that is completely random and I still see this clustering and the cluster going up, and I think that they change the price because that is what I see. I see the clusters going up, the price going up. Oh, the cluster, the changing or issuance is what is causing the price to go up. No, it's random. The price is random. So how is possible? There is no connection at all. And still, I see exactly all the features that you saw before. This is actually not some kind of invented issuance. It's the exact issuance. So the only thing I change here, okay, in this graph is the price. Instead of being the price of Bitcoin, it's some random price, but it's the issuance of Bitcoin. I didn't change that component. So how is possible that issuance of coins of Bitcoin is affecting in any possible way the price on the y-axis that is the price of a random coin? Simply because correlation doesn't mean causation in this graph. There is something that is happening in time, that is this cutting in half every time we have an halving. So it's a phenomenon that is happening in time in this very, very simple way, because in between nothing happens. This is why there are these jumps. So the only change in time for the issuance is when we have a jump like this. For the price, is a continuous thing. This is why it looks like a straight line. And the two have nothing to do with each other, and still they look like a line. It's a trick. It's an illusion. This is why you need to be trained to separate, cause and effect, and understand when there is a cause and when there is not a cause. The problem is, and so let me tell you, I don't get mad, and that is the worst example, but probably there are others in other charts, because it's not about putting down other model. I want people understand the truth, what Bitcoin tell us. Okay, so this is why we do science. It's not a social, it's not social justice. There is no social justice in science. Something is right, something is wrong. This is it. And some people are right. I should not attack the person. I should point out the problem with the model, with the understanding. Sometimes I mention the person because if you continue to do the same thing, if you don't care about understanding, if you don't want to have a public debate, why don't you have a public debate with me? So we discuss it, and we find the truth, not about who is right or who is wrong, but can we understand Bitcoin better? If I say something that is incorrect, I will want somebody to come to me and say, Giovanni, what you're saying, if you have an argument, if you have science, if it is not trolling, this is wrong what you say. You made a mistake here, or this is a bad interpretation. This is how you do science. And then you go forward. And this person is not going to be put down. There is no winner or loser. It's no debate. It's understanding. And so in that case, if I was the person that made a mistake, I still contributed because I made you think about this. This is how many scientists happen. They made some mistake in what they are saying. Galileo, when he described the tides, he had a bad understanding of how the tides work. Everything else that he mentioned was pretty much correct, but he had this problem with the tides. Well, we don't even remember. Most people don't even know that he was wrong on the tides. And then Newton came and said, no, Galileo was wrong. This is how it works, has to do with the moon and whatever. But he adored Galileo because he was an important step in building the knowledge. He say, Newton say, I'm a dwarf on the shoulder of giants. And he meant all the people, including Galileo, that came about. So this is how you do science. So if I do something wrong, but I contributed in bringing some knowledge or bringing some attention to Bitcoin as a scientific topic, I'm still a hero. I'm still a hero. Plan B could be a hero, but instead, plan B. But, he creates this bubble where only being right about, people will tell him, you're right, this is amazing, are allowed. I don't think that is good. It's not good for the community. It's not good for him. It's not good for Bitcoin. So that is my position. But anyway, he does exactly this. He does this. Instead, he has two things. He takes the issuance, but also the supply. And this is what stock to flow is. It's a ratio between these two things. And with supply, you can understand it's even worse, right? Because think about it. If supply grows in these little clusters. These ones are staying stable. They don't shift back and forth, and they are all random, but supply actually grows. So how could it be a measure of scarcity, supply itself, right? It's nonsense. If coins are growing, you have less scarcity. But, he divides it by this quantity, and supposedly this quantity goes down, so S2F goes up. It's a mess. But it's also based on this illusion that there is a correlation. In fact, if you see what he does, and we can look at the other graph, it's exactly this. So you see now it looks, instead of going to the left, it goes to the right. So we have S2F and on the bottom, and S2F is nothing else than the ratio between the supply and the issuance. So now that quantity, instead of decreasing, is going to increase because you are dividing by the issuance. But you see here, these are the clusters, but now they look more like what you're used, with the bubbles, etc., because it's less random with that cluster, because now we're talking about S2F is actually basically time. If you really understand what S2F is, it's time. So this is why it looks more like price versus time. But it's split in these little bubbles, right? These little clusters because of a jump in the issuance. So this is how it looks like. And here I did a simulation where I had a fake price, again, because this is the real data, what you see here below. And this is really what will happen if you didn't have bubbles. So I made a fake up price following the power law, and I didn't want any bubble to confuse us. And you can see I get these cluster twos, right? And this exactly they behave like the real ones, because I just simplified. Instead of having bubbles, I have something that, imagine kind of a crazy world where the power law is perfect in the price, instead of having these bubbles and having all these deviations. It's, because sometimes this is what we do in physics. We make these, they're called toy models, where these toy models where you simplify everything and you still want to understand, right? Because eliminate all the distractions, like Galileo did. He eliminated friction to understand what the real nature of motion was, and this was able to understand inertia. He was able to do this. So you can do a toy model where you eliminate the bubble, and then you say, see, in this case, I will not expect S2F to work at all. Why should it work? There is no bubbles, there is no, but still, you see how, and this is what you see here. is actually what a model, and I say S2F, but anybody that wants to make a model based on issuance, you will have to do something like that. You make a log plot. See, you make a log plot, because I have a log of S2F here, and I could do the log of issuance, whatever you like. I don't need S2F. I could just do it all on issuance. I could say issuance goes down. I'm going to make a model based on issuance. I don't even need this weird ratio between supply and issuance. I could just say it's inversely proportional. I make a model inversely proportional to the issuance, and then that model is predictive of the price of Bitcoin. To do that, you need to find some kind of a relationship between these two things, if that is your claim. And the way you do it, or at least the way Plan B did it, and people don't realize that because they think, oh, you are crazy doing power laws, but there are other people that don't do it. No, because S2F is based on a power law. Go back to his original article. He claims that exactly that is his first step. He tries to find a relationship between market cap or price and this quantity called S2F. And the way you do it, you will put this data point in a graph, in a log graph, and then you say, oh, there is some kind of a linear trend. We already show from here that is an illusion. This linear trend, remember, why is going to the left, because we only focus on issuance, but I could do an entire model like he did only on issuance. Forget about supply. It's the same thing. The only really thing that changes, the supply changes a little bit, but it's almost all there, in particular now. But it could all be based on the change in scarcity, right? Change in issuance. And so in this case, because he has two quantities, a little bit more complicated, it's growing instead of increasing. This quantity S2F, but it's exactly the same idea. And so this linearity that you see there, this growing that you see there, is nothing else than the same illusion that I just described, and hopefully I convince you that is an illusion. This is an illusion. This is why I'm so mad with S2F and frustrated, because it's an illusion. And I don't understand. This is what drives me nuts. I don't understand how Forbes magazine, that supposedly has very good analysts, there was this English huddle. You say, oh, but it's on Fidelity, book for investors about the Bitcoin. Now the S2F is. I want to talk with these guys that did this analysis. Did you understand that it is an illusion? Talk to me. Come to my X and let's discuss it. You're a professional. You're serious people, right? That got PhDs probably in finance. I don't know which things. I doubt there is a physicist that look at this, and I don't know. I want to know you. Let's have a discussion. Let's have a serious scientific debate, because I'm not going to insult you. I'm not going to say anything bad, but tell me that I am wrong in this being like an illusion, like a little children trick, magic trick. Like a professional will never fail for this, never. And I failed because in the beginning, when I saw S2F, I thought, oh, he's mentioning power law. I already published about power law for years. I don't know if he saw my article. I don't know if that is what inspired him to do it. I don't know. But it came later, right? After I published my stuff, even power law in time. And, I was happy. I was happy because, okay, now the power law in the family, it's great. And it made sense, right? At least initially, okay, there is something that is reduced, scarcity. I changed my scarcity idea after looking at the data. It was not the other way around. That it was not born with, I hate scarcity. I hated when I started to see the data didn't support that understanding of Bitcoin, because I want to understand Bitcoin. That is my mission. And so because I do all that all the time. This is how I started. When I read my first article on Bitcoin, it was like a little chart, and you can see it's pinned on my X, that had exponential behavior of Bitcoin. This is what I loved everything else up to that point that says exponential behavior of Bitcoin. And I don't have anything against exponentials, and they never done anything against me. I'm friend with a couple of exponentials. I have a couple of exponential friends. There are so many beautiful exponential in lives, but I went to look at the data, and the data didn't support Bitcoin being exponential. So I needed to make my own studies, my own understanding. Okay, so it is not exponential, what it is. This is how it goes. If you're a scientist, what you do. So I spent time differently from, I will say, 99.9999%, including these analysts, to actually understand it, not to just make some graphs, because everybody can make these graphs. If you know how to code, you can reproduce Plan B work or anybody else work. That is the beauty. And I realized, oh, this is garbage. This is why I say garbage. This is an illusion. This is this thing. There is no absolute. Instead of doing some fancy mathematics that you never know what it means. You get that response and then, okay, this is the response. But what it means, to me, is important to understand. So when I started to really dig in and understand what this meant, was like, can you imagine that there are millions of people, because literally there are millions of people following him, and on the news, on Forbes, and everybody, even if some people dismiss it, but mostly because it doesn't track so well the price anymore. And by the way, I don't know if you ever understood these plateaus that you see in Plan B. They are produced by these jumps, right? This is why you get these plateaus. They are actually the mean price. They are supposed to be the average price. They are not meant to be the top. People confuse. And that is the other thing that really upset me, because I never saw Plan B say, hey guys, by the way, when you think it's the top, it's not. It never corrects people. It's supposed to be the average. Why is it supposed to be the average? Because you're drawing a line. You see, I'm drawing a line there to make my model. My model is that line. The line represents the mean. So when I have my little staircase, because from this model, a staircase will come up. It's part of the jumps. Then that plateau is not the top, is the average value. So you can imagine, when he says 500,000, that is supposed to be the average value of Bitcoin, okay, after the halving. So I don't know why so many people fell, but it makes me hungry to think that so many people believe in smoke and mirrors. It's not even like, oh, there is some wrong assumption, etc. It's really, really, really this wrong. It's just nonsense. This is why I say it's nonsense. It's nonsense. And I hope I convince people. It's just, like if I can do this with a random price, and basically the same steps, the same constructions, the same logic that is at the core of S2F or any other model that is using this. So I'm attacking everybody, okay? Equal opportunity jerk, Giovanni. Anybody that's using something like this is doing bullshit. It's really garbage, okay? And you are scamming people, quote unquote, don't interpret it in the wrong way, or scamming even yourself. I don't think Plan B, because I talk with him, I don't think he's a scammer, okay? He's very convinced about his model. And of course, he identifies with him. And that is where we separate, because you should never identify with your science. You should separate from your science. So this is what I produce. This is my understanding. This is how you should do it. And then people can use it, can attack it. You should be actually one of the people that trying to find ways of still manning the opposition. This is how scientists do it. But I would love somebody to come and start to steal, to attack the power law, because it makes we understand more stuff. So far I just have trolls and people that tell me that I cannot take a lot of time, that it's completely laughable. It makes me understand I cannot. How can I even talk with people like that? Okay. And I want to address another thing and say, well, Giovanni, then can you not apply this to the power law? Can you not say that correlation doesn't mean causation? Good question, and we should do that. The difference is that in my case, first of all, if you look how the power law works, it's a continuous process. There are no these jumps. There is everywhere, right? Everywhere there is. Yes, there are the bubbles, but notice I don't have a picture here. I should have put it. Yeah, I don't have it. I wish I had it. But yeah, okay, we can use maybe this one, right? Because these are, so you see, these are, this is when, we see how, first of all, there are no jumps, right? There are the bubbles, and then there is this general trend that I'm telling you is the power law. So that is one good point, right? So one of the things that we can use this causation, correlation doesn't mean causation. Why it doesn't apply to this model? Because it's a continuous process. But also, I show you many times, if you throw away the bubble not by hand, by using statistical method, there is this thing called ransack, that by the way, the idea of using it was, I want to give credit, was from Chris Berger. So Chris had this very idea, and it's not that I didn't know, I knew about that method, but I didn't think about it, and I give him credit. You can eliminate the bubble by this method, and what you get the bottoms, and the bottoms follow the power law. So you start to see all this more information that is there, right? And on top of everything, now we propose, right? We cannot be sure of 100%, but we have two possible causes. There are these two things. One is adoption, right? We have adoption that behaves like a power law 2. Then we have a Metcalfe. The numbers we get are 3. Oh God, 8. It goes like t to the cube. Is there any other example? Yes, COVID. So you have all these spreading of information, because I know people associate a virus with something bad, but it's nothing else than, if you think about mechanism, right? It's spreading of information. So it completely makes sense. When you start to create a story like that is based on science, this is how you do science, right? You come up with mechanisms that are plausible. If the mechanism is plausible, and this is what that economist professor, he talked with me, he sent me a DM and say, Giovanni, I understand how you work, because I work with physicists myself, and I had to learn how they think, and you guys are right. This is how why you discover things, and economists don't, because you think about causes. And so if your cause is plausible, then you can make an argument, say, yes, in this case, it's reception when we do have a cause, because otherwise we will have to throw all the signs, right? Because when you do a graph, and we did it in our article, we made a power law of a falling object. A falling object is a power law, because it goes, if you studied a little bit of physics, the distance covered by a falling object is equal to 1/2 g, that is the acceleration due to gravity, 9.8 meters per second square, times the time that is going by since you drop the object. That t squared makes it this distance that the object covers, the time distance that is done, covered by the object while it's falling. It's a power law. And we show a graph that looks like straight line. And if you say, hey, correlation doesn't mean causation. In this case, yes, it does. Absolutely. Okay. And so in our case, we have this sequence of logic that is showing that you have something that is very close to the 2. Why is not 2? Because you have also an explanation, because it's not a perfect network, right? Remember that result 2 was done under this assumption that everybody is connected to everybody else. Actually, it makes sense. You will have been almost worried if it was too close to 2, because it doesn't make sense. So it will be a little bit, it means it's a little bit less efficient than something that is perfectly connected everywhere. So it's close to 2. It cannot be by chance, because if you have something like this that is very close to our virus spread, is very close to what Metcalfe, you expect Metcalfe. If this was something that didn't have anything to do with network, you will have to justify. So this is how you do science. Now, the best way to test this, and physicists are very lucky, because many times we have something sitting in our lab, and we can poke it, we can push it, we can change the parameters, and then we see our response, right? Sometimes you cannot do this. If you study a star, you have to do it passively. You have to wait for the star to do something, right? Like, you don't have a huge big stick, 5,000 light years long, and say, hey, star, do something. You cannot do that. Maybe one day, when we are cyborgs, we can go there and throw, some super weapon against the star and see how it behaves. But until we know how to do that, for now, with the moon, we can have lasers, they go to the moon and come back, so we can measure the distance, so we can throw like a probe against the planet and see how it behaves. But with a star, you need to collect passively information. Like here, we cannot change something. We can maybe study strange events, like, for example, You see how here around 4,250, if you go back to my graph of the price versus time, you know what that little dip is? That actually not little bit, big dip, right? So it's a big dip around 4,200. These are days from the Genesis block. That was COVID. And if you draw, I show this line, this graph all the time, but I should have added to the slides. But if you kind of connect the bottoms here, you can see that that little dip went there. And what it means is a test. It's like a kind of almost like an experiment. So it was this crazy event that happened. And our theory tells us that that is the bottom of this, where the miners are going to lose money. And the theory is very consistent and, kind of could make a prediction and say, we will never go below that. And in fact, what happened during that big experiment of COVID, it was a passive experiment because you don't control it, but this is how you can do it. If there is something happening to the star, and then it kind of follows what your theory says, then it's a confirmation of your theory. And so here, there too, there was that deep, boom. So you see, there is so much more information and more intelligence in this way of understanding Bitcoin than something that you kind of made up and is based on an illusion, that you can, with a certain confidence, because nothing in science is 100% true. You never see, this is another thing that people don't understand. Theories, even the strongest theory like relativity, quantum mechanics, you never prove them. We train people never to say that word. We never prove a theory, because a theory is always, if it is a valid scientific theory, can be only falsified. That means you can find inconsistency. Many times what happens, like with Newton and Einstein, right? Einstein came, they didn't abandon the Newtonian understanding of the world. We simply improved it. We added all these new things, like what happened when bodies start to travel very quickly, close to the speed of light, and then you need to modify the normal physics that we use every day, that is called Newtonian physics. So many times, if you have a theory like this, that probably is true because there is so much information there that cannot be made up. It's not an illusion, it's true. But maybe I'm missing something. Maybe somebody else can say, well, Giovanni, we should add also this component. Maybe scarcity has a role. And look at this where it works. You miss that. Oh, okay, thank you so much. I didn't think about that. Fantastic. Now we know more about Bitcoin. This is how it works. Okay. And so right now, I don't see any place for scarcity, in particular this change in issuance. For sure, maybe there are other measures of scarcity coming to place. I don't know. I will be interested to know from other scholars. See, part of what I'm doing, I'm trying to make a science of Bitcoin. And it's not that it's not, because there are a lot of papers that are published, but there are like one paper here, one paper there. I'm trying to put it together like in a theory so we understand Bitcoin, and Bitcoin does all these things. And, like more scientists coming. And then also scientists communicating this finding to the public, because that is also what is missing. People don't even know there are all these beautiful papers about Bitcoin. There is a paper, mostly this scientist called Sornet, that is one of my favorite physicists. He wrote books about bubbles in many different markets, not just Bitcoin bubbles, but also stock market bubbles. He has an entire book, like a popular book. It's not technical, and he wrote a lot of technical book. But he has a paper on Metcalfe, and they didn't know about me because I published in the very famous journal called Reddit. I'm making a joke. I published there versus publishing in a paper because I wanted to reach other Bitcoiners. I wanted to share my understanding with other Bitcoiners. And, I could have done both. I didn't. I'm going to write a paper on this time, so I can do both. You can do both. And, I published before them, and exactly was this Metcalfe thing. When I measured it, it was early on, so it was more like 1.5. Now it's more like 1.7, but it's exactly the same result. And they published an entire paper saying, oh, they called it generalized Metcalfe because it's not 2, it's close to 2. And so, serious scientists, Sornet is a worldly recognized, NASA uses him because some of these approaches that he has can be also used for other things relevant to NASA, like finding cracks on these big tanks that we have of fuel. You can use these because you can find the basically cracks in material behaves almost like cracks in the market, like bubbles or crashes of markets. So the same math can be applied to understand how to find cracks in a material. And so they work with him, to do this kind of work. See how physics can be used in many different things that don't seem related, like the crack in a material. It's related to stock markets. It's incredible. This is how physicists think. Okay, there is a connection there. We call universalities. And so I discovered this before they did. In fact, I even sent an email. They didn't answer me and say, oh, I'm admire of your work. If you ever want to do something together, I am here. But, probably they didn't see my email or whatever, or they maybe think I am a crazy guy. But I found this before they did, like a couple of years. But it was nice that another scientist found the same thing. So it's not made up, like real scientists are working on these things. When you combine them together, you see, when you combine these two things together, these two exponents, I get, so the real one that I measure, the exponent for the growth of Bitcoin is 5.71, so close to 6. And if you just multiply these two guys, these two numbers, you get 5.65. That is about 1% away. So this is the result that you get by combining this guy and this guy. Like if this price versus time was due to two different processes, addresses in time and price as a function of addresses, you combine them together, the exponent is 5.65. And that is about 1% difference from the slope of this red line. Causation, in this case, correlation means causation. I made a case. And I will publish a paper, and it will pass, I tell you, it will pass peer review, because we have already several scientists say, yes, this makes sense. So that is the difference between something that is an illusion, like, this thing, and it's a trick. And if I show you it is a trick and you continue to tell people, then you go from self-deluding, because I think this is what happened. This is my interpretation. This is my charitable interpretation of what happened. And it can happen to anybody. It could have happened to me, okay? It could have happened to me that you see this thing, you're all excited, say, whoa, there is this thing called stock to flow. It's in the Bitcoin standard. It's mentioned there as one of the important measures for gold and this. And now I see, there is a correlation. No, you're looking at an illusion. There is no correlation. I mean, there is correlation, but it's an illusion. And then you make an entire model with word talk about you, fidelity, put it in, tells to investors, we are telling a lie. I mean, can you understand the reliability? Somebody can sue them after they found out it's a lie, say, you told me a lie. You told me to buy Bitcoin based on a lie. We don't want that. We don't want that. This is why I get angry. It's not just, if it was like another model, like, okay, I have this idea and all the science was sound and all the steps, but, it was based on some other interpretation, then yes, welcome, great. It's great when there are more theory competing against each other. It's fantastic. This is how science works. Until one kind of, like, quote unquote, wins, because winning in science means being closer to the truth. You only can come closer to the truth. Okay, it's a continuous process. And this is how science works. So people sometimes misunderstand why I'm doing this is because I love Bitcoin and I love the truth. This all. And maybe my ways of doing it are a little bit weird for people, both because it's my character, but also my culture. But this is my intention. And I think maybe talking, it's easier to understand than writing, because it's a limited way of expressing yourself. So hopefully you understand better, because I really want you to understand this, because otherwise you will, think it is, you're thinking your understanding of Bitcoin will be based on a lie, because this is literally a lie. It's an illusion. It's like it doesn't exist. It's absurd. So hopefully you understand. We can talk another time more about the theory. This is what I wanted to do. But if you have a chance, please, and maybe we can have also. I will try to do this in a more regular way. I wanted to discuss this to tell you. I'm not saying that bubbles are not important. They are super important, very important. But for other reasons, then a shock, this is a supply shock. The supply shock doesn't exist. It's the wrong terminology, because Bitcoin is not like a normal set. You have to think in different way. You need to change your way of thinking about Bitcoin. It behaves more like a physical system than actually an asset. And so we can discuss this another time. What drive? My son is making a nice video. Maybe we can release the video, and then we can have another meeting where we discuss what really drives the bubble, why they are important, what is going on, and how maybe also we can use this information from the bubbles to do DCA, to do useful things, because that is not just theory to understand Bitcoin that is important, but also how we can use this knowledge for our own advantage, right? Doing better DCA, maybe multiplying our Bitcoin, and so on and so on. Because that is always like science is important and it's great, but if we can apply science, then it's also amazing, right? That is why science is important, because it's not just like this theoretical understanding of the universe, but also all the practical applications. So that is the idea. And then we can please also watch the video, about the theory, because it's not a model anymore, is what I'm trying to see. I know it sounds funny to some people, maybe they think that I'm trying to make it more important than it is, but it is. It's more important than it is than a model, because now it's a full theory of how Bitcoin works, all these different steps, all these different connections between all the different components of what happens around Bitcoin. I didn't invent this loop. I took it, maybe it's even from, I don't remember because I read it several times, but is this from the Bitcoin standard? I think it is. And actually it's nice. It's a place where we agree. I don't agree on all the scarcity stuff, but agree on this. This is beautiful. And the difference is, right, whoever did this had this incredible intuition about how Bitcoin works, this incredible, beautiful cycle. But what I did, I added the science behind it. I say, yes, every time there is one of these sections of this circle, we have something that actually supports this statement. It's not just a vague statement. There is data behind it, and there is science, there are mechanisms, and this is what the theory is doing. And plus, is giving a lot of importance to this inhibitory process. Like there are many mechanisms like that where you have something that curbs. Like in our video, if you watch it, the video that my son made about this theory, we say is like the brake of a car, or if you want to think about the thermostat, is whatever adjustment. These are called control systems. So Bitcoin has this control system, the body has this control system, the brain has these control systems. We want to do something, we are pushed by some desire, some drive, some instinct, but then we have the higher parts of the brain that say, hey, calm down, don't do it, it's dangerous, or slow down, or whatever. We have these inhibitory processes, and that is what is there at the core of Bitcoin, how it works. And this is why, and these kind of things, anytime you have some kind of iterative process, you have power laws. You can show it mathematically and logically. That is exactly what you have. And in fact, it will be completely weird that Bitcoin didn't have power law. And in fact, we see them everywhere. There are power laws of time. There are power laws between each other. Everything is a power law of something else. So these three fundamental parameters that are addresses, price, and hash rate, that are important things for the core of Bitcoin, that are all related to each other by power laws, and that are all power law of time. So we have value, human value through adoption. We have energy that Taylor mentioned all the time, how fundamental it is for Bitcoin, and we have time itself. So all these things, right? And price, because price is value, right? Value of the system, and it's fantastic. It's everything you will want to have in Bitcoin, and is there. It's real. It's science. The only thing that I think, if you resist this model, there is only one reason: is this power of 6 instead of being an exponential, because that little trick, that little magic fakery of that correlation, between halving and issuance and price, that doesn't exist because it's a trick, tells you that the price is going to exponential, is going to millions, and if you this cycle is going to be 10 million next cycle. That doesn't exist. It's an illusion. And instead, you have to be settling on T to the 6. That is a super parabola. So when people talk about parabolic price, the price went parabolic. Well, Bitcoin is parabolic all the time, super parabolic. But it's not going to make you millionaire the day after tomorrow. It's going to take its time. So if you don't, if you are, to me, it's almost like a degen message. There is not much difference between these people and shitcoiners at this point. So why don't you listen to Bitcoin? Why don't you accept what Bitcoin wants for itself? Because it knows, has all this mechanism of self-regulation on purpose. It's also the thing that doesn't make it a .com bubble. Is also what it doesn't make it a tulip. It goes in both directions. It's what makes it survive when there is COVID and bounce back. So it means stability, it means strength, it means power. Okay, it means all these things. So you get both ways. You don't get millionaire the day after tomorrow. You have to wait a little bit longer. At the same time, it's also going to stay here, and it's predictable because you can use this idea of scaling that is a fundamental component of Bitcoin to actually be kind of sure. In science, there is nothing sure, but this is one of the most surest things that we have in science when we have a scaling phenomena. Scaling phenomena are very stable. This is why, I made this analogy of Bitcoin going from, literally, if you look at how the price change and you find an analogy that is equivalent, it's not just like poetry, it's actually based on the numbers. It's the equivalent of taking a speck of dust that is 100 of a millimeter. So you would need a microscope to see this dust speck all the way to Mount Everest in 15 years. So if you think that there is a process that behave in this way and they grew in this very regular fashion, because a straight line, this is what it means, right? Regular fashion. The scaling happen in a very precise manner. Do you think that it will change because of you or because of your desires or because of your wishes when it goes another magnitude up, when it did it for 9? It's not going to do it. It's going to continue to behave in that very regular fashion because that is its DNA. If you understand anything about science, you agree with that. Yes, that is what the system does. It's amazing, it's incredible. I don't understand it, how it's possible, but this is what it's going to do. This is how a scientist needs to think about this. I cannot come up with any other conclusion. Now, given that it's not planets, there is always some possibility that something happens, maybe a war happens, maybe something catastrophic, but ETFs are not that thing, because ETFs are nothing else than the right event at the right time that makes this system go to the next order of magnitude. It's the right proportional thing. Another way about thinking about scaling processes is everything in proportion. So think about a triangle, right? You can draw a triangle. I gave this as one of my expos, so forgive me, it's something that you heard before, maybe some people didn't. Draw an imaginary triangle at any point of this graph of price versus time, using that red curve as your hypotenuse, and then one of the sides is the price, right? It's the log of the price, and the other one is the log of time, and then make it bigger. You're scaling it up. This is how we say in physics. You're looking at the scaling property of the system. So make it bigger and bigger and bigger. And this is how you can predict. It's the only time. There are 2 times when in science we can predict things, and we have done it over and over again. So we know it works. Is when you have a periodic system, like in the bubbles, and Bitcoin is periodic, and there are reasons why it's periodic, and when you can scale something, because we use it all the time. We use it to predict how a tooth grows, how a mountain grows, different phenomena in time that we can predict how they are going to evolve, because we know they are going to do it in this scaling variant system way. So the scaling variant, remember, means simply you make this triangle bigger and bigger, and everything will grow in proportion. It's very simple, very straightforward, very powerful thing. If people are not used, if an economist like this Corey from Swan that argues with me and you think that I'm a charlatan, is because he doesn't understand physics. He doesn't understand what scaling variance means. I know why he does it. Okay, different from Plan B, he cares about. Okay, I will say something bad about the Plan B, but I know the core, he cares about the community. Okay, and he saw so many charlatans that he thinks I am another one. But you know me. If somebody knows me, I am the anti-charlatan, the opposite. Because otherwise I will say Lambo, exponential, and saying the contrary, and say Bitcoin is taking its time. But I'm also, because I'm a scientist, I'm coherent with my understanding, and my understanding is Bitcoin shows this scaling variant property, so we can use. That is one of a few times that is say one when things are periodic, and the other time when scientists know how to make predictions and they are very confident because they have done this so many times and the world works in that way, is when you have something that is scaling variant, because changing for that system will mean something is wrong with the system. So this is why you're safe in your as much as a scientist can be, right? It's still a scientific prediction. It's not like saying 100%. There is nothing 100%. But you can be very confident that this is continued to be. And if it doesn't, then the right approach is, okay, it looked like it behaving for 15 years in a scaling variant way. It didn't. So something changed. So it's also a tool to understand, to kind of almost like diagnostic tool to tell that something happened. And it's not that the model is broken. That is another way. People don't know the terminology. They don't know how to think about science. They use all the wrong concept and terminology. It's a fact. It's an historical fact. At a minimum, it's an historical fact that he behaving that way. And we needed to understand, why did he do it in this way? Why for 15 years behaving this way? At a minimum, is something that people will continue to study for centuries. Why this system behaving this way? Now, in 3 years from now, it doesn't, and it changed, then it will still help us. This approach will help us to measure the change and see how much it changed and why it changed and what is going on. It's still a useful thing. Remember, it's not that we threw away Newtonian physics when Einstein came about. We expand this knowledge. And many times we use that Newtonian because it's not, unless you're traveling close to the speed of light, we will make things more complicated. So it's a good approximation of how nature works. So this is how you continue to do science, okay? And you can see I'm extremely coherent and consistent in the things I'm saying. People can misinterpret, and maybe if I don't have the patience and go to my videos and listen what I'm saying, this is why it takes me 2 hours, because I'm trying to explain things as precisely and as clearly possible. And if you don't have a patience, then you will think, oh, this guy, is another Plan B or this and this other, and I'm not. I am the anti of all that, okay? And it's, in the end, I always say, it's not about me. There is not, I'm just a scientist of Bitcoin. I'm trying to tell you what I'm learning about Bitcoin. It's all about Bitcoin, about understanding Bitcoin. So when I say, oh, we can predict this, etc., it's not me. It's Bitcoin. It's about Bitcoin. Our regular, beautiful, amazing, has all these properties. It's all about that, nothing else. Okay. Sorry if I took all this time. Hopefully you learned something. And maybe everybody left. So let me read some of your questions, because I'm sure you have some questions. And then I will just take the floor. You take the floor and ask some more questions, and we can interact. And we can go for maybe another 15, 20 minutes, and then we can end it. Okay, let me see. This is what causes the FOMO. Okay, let me see. Let me go back. Okay. You can see the presentation view, you can still the standard of interview. So you miss the, you didn't miss the, you saw the slides, right? You saw the slides. Maybe you didn't see them big. Yeah, the points were daily. Basically, these points that you saw were each point represent a day. So it was the average price for that day, or the closing price, the close of the day for that price, and the average amount, or maybe the total amount of coins for that day. And so this is why you see them all over the place. Yeah, timestamps will be great. Appreciate. Yeah, please, Madis, can you do that? If you're still there, can you please add timestamps when you have a chance? Because he knows how to do it. Yeah, you don't see the full screen. I don't know why I made it full screen at a certain point, but did you see the slides? Hopefully you saw the slides, even if they were no maximized. I don't know why it didn't happen. I have a question. Power laws. I was wondering how you think about inflation, which exponential does interact. Actually, it turns out if you just simply subtract, because most of my models, when I add inflation, and I did several times, I simply I can do it in different way. I can take M1, and I did also that. But one way to do it is, hey, let me add some arbitrary amount of inflation, and you can exaggerate it. Where I have made some graphs. I don't know if you saw it, but maybe after the call, I can put it again, and so you can check it. So Ken Alan, just look at my post after this. I made a graph where I have a normal power law, and then I show you what happened if I subtract every year some inflation, arbitrary inflation. It can be 5%, 6%, 7%. I think in that graph I did something crazy like 6%, but it's relatively big, right? And then if you do that, you still get a power law that is really cool, but now the power law will be slightly tilted down, and that will be the adjusted power law relatively to inflation. And it's basically after 10 years, and we were discussing this with some other follower. It turns out that in 10 years, if you compare it with today, but that is the problem, right? But okay, I need to finish my sentences and then elaborate. So finishing the sentence is 500,000. So it will turn out to be equivalent in 10 years from now, we will have 1 million. But if you adjust for some crazy amount of inflation, and hopefully it's less than that, it will be 500 of today's money. The problem with that is today's money relatively to what? Because there are certain things that are, the inflation goes up. Not everything grows with the same inflation rate, right? So there will be certain things that maybe are going to be growing up faster in terms of inflation that you want to buy with that money, and other things not so much. But it's one way of seeing and understanding it. So inflation has a relatively small, as it should be, right? Because Bitcoin should be something that protects you from inflation. So it has a relatively small impact over a very long period of time. And to get that factor of 2, I had really to exaggerate the inflation. So I could make a graph maybe with different amounts of inflation so you can see what happens. But they are going to be all power laws, just with slightly different slopes. And many people discuss that. They say, oh, what about if we were using pesos? Well, what about it? So one of the things that people don't understand is why I made this meme of the flying cow, right? When we do science, we always look at the simplest possible example. If you take a physics class, we will teach you how an object falls, and we always say, well, let's ignore friction. And some people resist that. They say, well, but the world has friction. I need to understand first how it works without friction. If you don't understand, this is why we didn't do progress for thousands of years, because people were confusing. We're confusing what is the main phenomena with everything else that confuses the phenomena. Friction is not how the universe works, because if you go almost everywhere in the universe, there is no air. And so the air is an exceptional case, okay? And then it's not that we ignore it all the time. Later, right, if you want to shoot a cannon, because eventually people use physics, unfortunately, for things like that, how to hit the enemies with a cannon. We have all these, today we do it all with computers, etc., but they're using the laws of physics. You want to introduce friction, because otherwise you will not be able to hit that target, in particular if it is very far. But you do it later. You add that complication. Say, okay, now once I understood what happens without friction, I can add friction. So it's equivalent. Adding inflation, it's adding one component to make understand better what happens when I make complication, when I add a complication. So first we understand without, and then we add things. And then you can add wind, okay? Wind starts to be a little bit more complicated. Friction is relatively simple, and you can modify the equation. You add that component, okay? This is this amount of friction, but also friction. It depends on, are you talking about water, like you're shooting a torpedo? You're talking about being in air. Are you talking being in the stratosphere, where the atmosphere is very thin? If you're talking about dogfights between airplanes, so you have to understand the situation. And then you can add all these complications, and you can, that is part of science. And then you say, well, where is wind? Okay, where is wind? Okay, how strong is the wind? In which direction? And you can add, because when we do this calculation in naval battles, they need to calculate. This is why they have computer. They measure the wind, they measure all these things. Okay, I need to shoot my cannon in this direction at this angle because of all this factor. You can add it. But imagine now there is a storm, there is a huge big storm, like a hurricane. They are not going to even fight. They are not even going to fight because it doesn't make any sense, right? To fight in such weather condition. You need to take your ship back to the port, not shoot stuff. So the pesos example is like hurricane. And it's not that we cannot understand hurricane. Then you basically change the topic. You're not talking about gravity anymore. You're talking about studying hurricanes, because now gravity becomes the small correction, and the hurricane is the main phenomena. Is the main phenomena that you study. And it's not that we cannot study, but it's so complex and difficult, and you need to come up with approximations, basically a new science almost, because scientists, physicists even study hurricanes, but it becomes a study of hurricanes. So if you bring the peso example, you are telling me to study the pesos, not Bitcoin, because the peso is what dominates. It dominates over Bitcoin. So please don't make that example ever anymore. It doesn't mean anything. I mean, it means, but you're asking me to study the peso, but I don't want to study the peso. I want to study Bitcoin. Bitcoin, maybe. So it's a reasonable question to ask, given the horrible, because 4%, 2%, we should have zero inflation. We should be like Bitcoin anti-inflationary, no inflation, because inflation is a made-up bullshit that they use to control us. And so it should be zero or nothing, or better. We should all gain, not lose. But it's a good, reasonable question to say, okay, how we adjust the model with some constant growth of inflation, and we can do it. And I did it, and I show you. If you do it with the SP 500, it makes you lose almost everything. I have graphs like that where I show in the last 25 years where the SP 500 almost barely. It's crazy. You're not making any money. You're almost like basically beating barely inflation with the S&P 500. While you see Bitcoin going like this, I don't know if you ever saw that graph. It looks like literally Godzilla. It's like this Godzilla thing in comparison with this tiny little bullshit SP 500 thing. And then you like, why anybody would want to buy a SP 500 when you see this monster? I can post it again, the chart where you see this monster Bitcoin, became Godzilla literally, and then the SP 500. And it's not even fair because to make it comparable, because Bitcoin is traded every day, and so you have much more data. I had to take 25 years equivalent to have the same number of days, because the SP 500, they close the market during the holidays and so on. So to catch up and have the same number of points, I had to add 25. So it's even like, okay, use SP 500, give it 25, or see what you can do in 25 versus 15 years of Bitcoin, and Bitcoin destroys SP 500. And I adjusted in these 15 years for inflation. You can see it's a small little correction. So these are good questions, but please start to think like scientists about this kind of things. Okay, this is why sometimes I make a little bit fun. Hopefully it's not offensive, but I made this flying cow. I say, yeah, look, checkmate physicist. Clouds fly during a hurricane. You see, Newton, your little garbage theory of gravity doesn't work, because I found this crazy exception when cows flies. Who is a silly person? The person that thinks that he is doing a checkmate to Newton. You don't understand what is going on. Does it make sense? Does it make sense what I'm saying? Um, okay. BTC is also an ego test, and it prevents people from taking information. Unfortunately, right, for me too, because of course, what is happening with me. I want to share with you. It's a little bit. It's diff. Of course, I'm happy. Yeah, the other day I did this interview with these Italian guys, and that's 30 years I'm not going. I'm not being in that country, and I see some countrymen. I'm famous over there. Uh, it's exciting, right? But it's also a bird. Sometimes it's a bird because you have to deal with trolls, but also what if I'm saying something stupid? It's not even in particular because I'm worried about you guys. You trust what I'm saying, and then I'm telling you something stupid, and it's a big responsibility. I take it like that, and so it's a burden sometimes. But I do it because it is exciting, and also it's a service. It's a service to the community. We are sharing these things, so somebody needs to do it. So I'm taking it with the bad and the good thing. I'm not making millions out of this, and that is the other component when people say, "Oh, you're monetized." Yeah, I have a Patreon account that asks people, please join our community, donate, $5. Like it's ridiculous because I'm doing it almost like symbolically. And if I can pay my rent, I'm fine. My son is helping me. I told him, quit your job. He was having a job in Estonia. Quit your job. Join me so we can make these videos. We can educate. Is it something that the community should cherish and support? I think so. If we the moment we are doing something stupid like asking people to pay $1,000 for a course, then call me scammer and do everything against me because you have a right to do it then. But if I ask a stupid $5 that people throw away for stupid things to help us to do all these things that we are doing for the community, and so I can focus on this 100% instead of selling myself to some kind of corporation and doing this for Wall Street instead of doing it for the people, I think it's ethical and transparent, and then talking to you directly, and I don't think I'm doing anything wrong, and people benefit from it because we talk about science. If you come to our Discord, we talk about books, we read scale. It's not just reading charts. And if I make some charts, and these are useful tools that can help you because it tells you about the cycles, and I share my IP with you for something basically symbolic, I don't see what is wrong, and I would like the community to help me and also keep me on the right track. If the moment that I'm becoming a charlatan, or I say something bullshit, or I charge people hundreds of dollars or thousands of dollars for something that I could, then yeah, call me out and call me all possible horrible names because they deserve it, but I don't think right now I do. I think there are two kind of people. There are the people that don't know, they don't know me. Maybe if they heard a little snippet, they think, and I think, for example, Corey from Swan is that. Like, he's a good guy. There was some misunderstanding between us. If you ever talk with him, tell him Giovanni wants to be your friend. Tell him, okay? He blocked me. I'm sad that Corey blocked me. I'm not sad that Plan B blocked me because I think he's a good force. Corey is a good force. I don't remember his name, whatever his name is. Corey from Swan, from the bird people. I call them the bird people because I'm trying to be fun. But he's a good guy. He wants to protect the community. He was against Plan B at a certain point. So he probably misunderstood what I'm trying to say to people and why I'm doing it. So I think it's a pity that we are fighting. We should hopefully I see him in a conference. I talk with him. He will get to know me. We resolve this thing. Or tell him, hey, Giovanni wants to be your friend. Go and watch his videos. I say he's a cool guy. But I know why he's doing it. And then so there is these people, and then there are all the other sheep people. Blah blah blah. They click the button because they see Corey says that. They don't know me. They trust Corey, so they join the bandwagon. And then there are the people that hate my message with so much strength because they want exponential growth, and they don't care if that damages Bitcoin, if that damages people. They don't care. It's very selfish and degen. It's basically degen behavior. It's not very different from being a shitcoiner. It's kind of like the same. And then there are like the trolls that just have fun and they hate somebody having some. I don't care about popularity. They think that I care. I don't. sometime I would like actually to go back to do the things I was doing, but there is no back. There is no back because right now I have for me this is a service to the community, and so these are the only people, And then there are the people that send me DMs and say thank you. I didn't think I wanted to invest in Bitcoin, but after listening you talking about all these things, I think actually there is something to it. It's not just another speculative bubble. I really now start to, and for every 10 trolls, there is one person like that. It lights up my day. I feel happy that somebody bought Bitcoin and I orange pilled him, and I am so happy. That is motivates me. It's what makes me want to. I was a little bit depressed before this. I was doing a lot of different things in my life, and I wanted to find the right direction. And since I found this direction, and there is like, if I can orange peel a person every 5 days, that is all what I need. That is amazing. And it doesn't matter how much resistance I get. That to me is all what is needed. That I did my duty. So, okay. Yeah, that is the important thing. These bluebird dogs say, this is great and very assuring about the nature of BC. Exactly, right? That is the message, that we have this very strong, because all these things, all these power laws and these inhibitory loops, they are all about how powerful this system is. It's like it will really take like something like a war to affect it, and it's going to continue. It's going to scale up in that way. It's almost like it's an irresistible force. It's an irresistible force. It is, and this is what CNBC doesn't understand. They will never show this graph, never, because this means Bitcoin is different from anything else. Probably they even think there is some kind of liability if they start to say, is this irresistible train that it will never stop, will continue. Now, and that is the other criticism when people say, well, that is stupid, because are you saying that it's going to 100? First of all, remember, right? It's going slowing down. So it's going to take 10 years to go to 1 million. To go to 10 million is going to take even longer. So it's actually slowing down because this is what it needs, right? To grow, it needs to slow down, because otherwise it will be a very unhealthy growth. So it takes time, first of all. And I think we can go all the way to 10 million Bitcoin. There is no physical limit to that because it's trying to absorb the entire wealth of the world. So there is nothing wrong thinking that it will go all the way. So we're talking about, at this point, maybe 25 years. I didn't calculate it yet. I think it's about 25 years when it's going to be $10 million. I can recalculate it. But at that point, then, of course, at a certain point, it's going to taper. But, you can modify this model where you add a little bit of tapering, and it's going to kind of saturate, right? But why not? I mean, it's possible. I say all the time. Thank you so much, Bluebird Dog. That was so incredibly generous from you. Thank you so much. It's not impossible, though, that if the economy in 25 years from now, I don't know if I posted online where there was this conference, Taylor was there. It was all a conference about abundance, from this guy called Peter Diamandis. He was like actually a classmate. He wrote a book called Abundance. In fact, actually, I'm going to add it to our reading list. We have a reading list in the Discord channel. We should add that book. It's called Abundance. It's beautiful, and the cover is aluminum. And you know why it's aluminum? Anybody knows why he used aluminum as a symbol of abundance? Anybody in the chat? Anybody knows? This book called Abundance, that I suggest you to read, is called, that is the title, Abundance, from Peter Diamandis. And he's a medical doctor, but he's also interested in technologies. And he was a classmate at MIT with Saylor. And all the book is about how the economy is going towards this era of abundance. This is going to be in our future. And this relevance with Bitcoin is Bitcoin can be the monetary system of abundance because it can absorb everything. It can absorb all the money. In fact, it can continue to go up forever. Yeah, it can. If the economy goes up forever and we have AI and nanotechnology and we mine asteroids and the economy goes much higher than it is right now, then a Bitcoin can absorb that, even be finite. It can see, this is the beauty of Bitcoin. It can be finite and infinite at the same time, infinite in the same time. That is the magic of Bitcoin. And so why not? It could go, in theory, we don't know. Who knows what happened 25 years from now? All what you can do is, for now, it looks like this. I don't want to complicate my model or my theory by adding some extra piece. If the data tell us that we are taking it off, we can adjust it. Like this is how we do it. First you do Newtonian physics and then you do relativity. You don't add things that are not necessary to the theory because you make it more complicated. That is other thing that people don't understand. Make simpler the theory, better it is, because this is how nature works. It likes simple things. And so anybody can guess. I'm going to give you a free indicator if you can. Like free indicator for you instead of spending $5 for it. I'm going to give it for you, free power law indicator. Anybody knows why Peter Diamandis used, like the cover is like aluminum foil. It looks like an aluminum foil, the cover of the book. Why did he use that as a symbol of abundance? Anybody wants to make a guess? In the chat, maybe everybody's asleep or left. Maybe nobody wants to take a guess. Okay, I will tell you. You lost an opportunity there. It's because kind of what happened is aluminum was one of the most precious things in the world until, I don't remember exactly that, but less than 100 years ago. In fact, I don't know if if anybody knows this. The top of the Empire State Building, that was built in the 30s. It's a triangle, it's a pyramid made of aluminum. And the reason is that that little pyramid, that is the tip, was so expensive, and that it was more expensive than gold. Aluminum was more expensive than gold. And so as a sign of wealth and power, right, because New York wanted to be this was before the war, so there was this aspiration for the United States to become, the new superpower, and New York was the center of that. So it was a kind of a way of flexing, right? Like the rappers say, we are flexing with aluminum, instead of, imagine somebody goes around with Blink and it has aluminum chains instead of gold chains. But at that time, will have made sense because it was more expensive than gold. So we were flexing. And the reason why it was expensive is that we didn't find yet a very efficient method of extracting it. So they knew how to extract it right from the minerals, because anytime you have a metal, you have to go through some kind of a process, right? So metals are easier than others. This is why copper is very easy to extract. This is why it was one of the first metals that humans used. And then gold, relatively easy. But aluminum was very complicated, required a lot of kind of energy. So Ken Allen, you kind of guessed it right and you tried. So contact me if you're on X. Send me your trading view in DM, and I will send you the indicators, okay? Because I want to keep my word. So do that, please, when you have a chance. You have my X? Do you have my X? I think so, right? I can give it to you. This is my X. Let me find it. So, but anyway, so what happened is that they didn't know. This is my X, by the way. And if you don't know, if you are not on my X, please come. Everybody, come to my X. So come there. Send me Kev Allen. Send me your trading view, and I will add you for free to both indicators. We have two nice indicators. Just tell your friends that how much you like them, because you will like them. And at a certain point, we will make a video about the indicators. But my son also made a video, so whenever you have a chance, if you find them useful, plus come to join us in our Discord. We like to have people in our Discord. We have a little community. It's through Patreon. You will have to do it through Patreon, okay? So they finally found a way of extracting aluminum It was relatively inexpensive, and this is why aluminum now it's the most abundant among the metals, right? It's very precious because you can make airplanes out of it. You can make a nice bike. Get it. It's free. TradingView is free. So you get free TradingView, sign up, and then we can also teach you how to use it. I will also give you a link to the Discord community just for free, just to try to answer the question and participate. So join the community, get the indicators, and get TradingView for free. The TradingView is free, and then we will show you how to use it, because you can see it's beautiful. You can see Bitcoin price every day. You can track it with the indicators, but also if you want to track other assets, like, just to see how shitty they are in comparison with Bitcoin, you want to look what it's SP500. That allows you to look at all these different assets live. You can have a daily, you can have minutes, so it's free. If you don't have it, actually, I suggest everybody to get TradingView. It has these beautiful charts where you can visualize different things, and it's free. Like, we have a professional version that I'm subscribed to, because you can do more things with it, but otherwise you can just join for free, and then you can use the indicators. And if anybody else is interested, I'm sorry if I pitch myself a little bit, but it's more about growing the community than anything else. You can do it through Patreon. I can give you my Patreon link, and then you get in the Discord, and it's called Scale Invariant. This is my name here, of course. It's like this. And we give 2 indicators. One is basically, I don't know if you ever saw this spiral. By the way, these charts are also free in my. The charts are also free if you go in X and you click View More. Under my profile, there is the spiral indicator and there is the normal indicator. So they are free, but they are static. You cannot interact with them. They're kind of a little bit simpler. Then I made 2 indicators that you can watch on TradingView, and you can use them, etc. And they are through the Patreon. The Patreon also gives you access to the Discord. We have about 300 people right now, something like that. We have 2 times a week. We have classes where we talk. It's not just about the charts. We talk about the power law, the significance. I take questions from people. Like, we have a question and answer session. And people talk. They know each other. Everybody's helping. They are making all these modes of the charts. People are discovering new things. It's really cool. And we talk also about science. For example, we read together this book Scale. It is one of the best books about understanding how these power law kind of phenomena are everywhere around us, and we make connection with Bitcoin. I also have a list of books that eventually want to cover, there is one that's called The Physics of Wall Street. And there are many different interesting books to show how we can use science to understand investments and the stock market, whatever. So it's really like a project that I'm doing out of passion and love. And my goal, because I try to be transparent, is if I have enough people that support this project, is that I can pay, my son and me living expenses, just a little bit. And then if we reach that goal, we are happy with that. And so we can put all our energy and all our time in this thing that we kind of already doing. Eventually, I want to create like an institute, like a real. There are many of these institutes around the world. In fact, even the one where that author of the book Scale, he works for these Santa Fe institutes, and they study all these complex phenomena. But I want to do something similar and make an institute where other scientists can come and study, dedicate their life to Bitcoin and explore Bitcoin like a science topic. So that is my goal, long-term goal. Right now, there are I think was it Stanford or Cornell, one of these 2 universities, they accepted the first degree in Bitcoin, like Bitcoin science. And so I want to actually make connection with that group, and that will be really cool, to study Bitcoin like if it was a scientific topic, because it is. So that is my long-term goal. Anyway, so if you guys, BTC price prediction, look, it's not about making prediction. It's more about understanding the long-term trajectory of Bitcoin. The ones that I care about is like, giving a feeling of where we are going, like 1 million, say all the time, 1 million about 10 years from now, because this is what the graph tells us. If you want to know the top, the bottom, if we can, and it's important to do it, but it's more about understanding where we are in the cycle. So if you want to do DCA, if you want to, maybe start to rebalance your portfolio, it depends on your style. Like if we are coming closer and closer to a peak, stop buying. Buy back when we go back to the bottom, because the theory has very strong prediction about the cycles being there, reaching a top, going back to the bottom. All these are part of the scientific understanding of Bitcoin. So we stick with it, and then we can use it to multiply our Bitcoin if we know what we're doing with care, with basically like if we are sending a rocket to the moon. That is the same approach. We want to do something challenging, but based on science. It's no TA. This is not TA. We are not doing TA. We are not connecting two dots on a chart. We are trying to reason. We're trying to use science. We're trying to use information, like if it was a scientific problem. And then, because there is a risk, there are individual decisions, that these are all up to you. All what I do here is to educate. This is just education, basically, about the science behind. And then you use it as you like. I can give you some suggestion. I can give you some general ideas, but then you take the information and use it. Because also, it would be illegal for me to do that, because I'm not a financial advisor. It's important that I make that statement. I'm not a financial advisor. I'm a scientist, and I'm trying to use science to understand how Bitcoin behaves. And then the decision is all up to you. So I have to be I think I will be a little bit more careful since now on, in particular because of all the pushback I got when I start to say this and this other. I can tell you, okay, the model or the theory makes this range of prediction with these probabilities, and then use that information yourself. So the best is following me on Twitter, because kind of make that range and that probability. And I think I will start to actually to associate probabilities, so people understand it's more like a science exercise than just telling you this is what it's going to be and so on. I don't want to mislead people. It's very, very important. I'm trying to do the opposite. I'm trying to educate people. Okay. Now, probably take this last question. Then, unless there is a new question, we will stop here, and then hopefully we can have this on a regular basis. Bruno was supposed to join us. Maybe my son is going to join us next time, and we can have it more like a kind of a dialogue, etc. I didn't get what you random coin demonstrated. If I understood correctly, you sample price for a power law plus. So let me tell you one more time. First I show you with Bitcoin. I say, look, Bitcoin is doing its own thing. The jumping is doing its own thing. We are unrelated. And the scene, there is this illusion that one follows the other. Or even worse, when the jumping causes the price to change. And then I say, you could still doubt me, because you can say, I don't believe you. I think actually this trend of Bitcoin is due to the jump. And then I say, okay, let me spice up the situation. Let me make it a little bit more interesting. Let's not use the real price. Let me make a random price. Kind of something that kind of looks like Bitcoin, but instead of a power of 6, for example, make me something completely different. Power of 2, power of 3, power of 7.3, whatever. So it's a made-up coin. So there is a trend plus some random noise on top, right? So the prices are completely random, plus there is some kind of random, because also it's in one of the videos in the channel. Go and browse among my videos, and I'm writing also a Medium article, basically kind of what I'm mentioning here, but going more in details. But I say, imagine now, and I randomize in that little video. I randomize even the exponent. So one time is 2.3, the other time is 3.4. So it's obvious it is random. It's like it represents some kind of crazy coin, random coin, whatever you want to call it. And then it's completely random. There is no doubt. At that point, and they kept the same issuance. So the issuance is the same, and now it's not the issuance of a coin; it's the issuance of Bitcoin. So you have it's like, have you ever seen these sites? I need to put it in my article, and also I will make a post about that. There is a site with, remember what is, maybe you guys know, where they show all these funny correlations that have no sense at all, like the number of pirates in the world versus the ownership of vinyl records. Why these two things should be connected at all? And when you actually take the real data, it's not a meme. If pirates went down, in the last century, and probably they are, right? Because there are some pirates in the world, in Somalia, wherever they are, but in general, there are much less pirates than 200 years ago, right? If a pirates went down, and also the number of people that own vinyl records, you will find a correlation, because they both went down in time, right? And if you plot one versus the other, it will look like they are correlated. It's so absurd. But it's same thing. So basically, I was trying to do the same thing, where I made up something completely crazy, and that didn't have anything to do with the issuance of Bitcoin. And it looks exactly like, you can see the two graphs when you compare it. And if you can always, I will post this video so you can go back and check it. They look exactly the same. So the fact that you're saying our eyes looks for that trend, they say, oh, look, it looks like it has to do with these jumps in the issuance. It's an illusion. And that is exactly the illusion. Imagine then that illusion. I say, oh, that means there is a correlation. So I can draw a line through that, and the line is my model. That is what S2F did. Well, this is what Plan B did with S2F. He exactly did that. Go back to his original article. What I say is an illusion. He took it as his model. You understand? This is what he did. He took that illusion as his model. He says that he say what I'm telling you, that it's correlation is not causation. He say it is, when it's clear that it is an illusion. And then from that he makes a model. And of course the model, we cannot follow the price, because it's based on this assumption that there is like a connection that is fake. And in particular, because S2F, even worse, is actually time. It's a deformation of time. If you look at what it is stock over the the flow. The flow is the change in stock over time. So you're basically dividing for something like supply divide time, right? If you do the math, it becomes time. So he has time in the x-axis, and then he draws that line. Of course, it's going to follow the price somehow, but it's all an illusion. But in addition to that illusion, there is this idea that actually every 4 years the price goes up by 10, because this is a conclusion, right? That they arrive to that conclusion because the slope of that curve is 3, and when you take the exponent of 3 to the 2, basically it's 3 something, you get 5, you get 10, right? And so it basically his claim is every 4 years we go up by 10 times in price, and it's all based on an illusion. And so this is why I get upset about that approach, because it's a lie in a certain sense, and you're lying to hundreds of thousands of people that follow you, and you don't take responsibility, and you're feeding them a childish lie. Because if you are trained, to you that is childish. To me, when I look at it, I say, how is possible that people believe this craziness? And not just normal people, they don't know how to read the charts, but analysts, Fidelity, people, that made the prospectus for investors. They can be sued. Say, you were a vet because vet incompetent. You didn't realize that it was an illusion. It's that serious. It's ridiculous. So that is what that tried to demonstrate. That I can get the same kind of behavior that you believe it's actually a trend from a random price. So if it is there with a random price, it can be with anything, right? It means it's an illusion. I mean, I already explained you from the logic that even with Bitcoin price is an illusion. But then I wanted to double down and say, look, you see how I get the trend? This is what convinces people. They see the trend and they think that correlation is causation when it's the worst possible case of correlation doesn't lead to causation. It's not always, sometimes, and you have to be very careful when is that sometime. Other times, yes, like in the power law, we have causation. In the case of this BS of a changing issuance, we don't. All right. So unless there is and then there is deep 33P coaching. I don't know if you're still there with us. Yeah, Argentina is such a beautiful. Oh no, actually, no name is from Argentina. Sorry for that. Yeah, no name. It's a beautiful country. Unfortunately, you have a bad money, but there is Bitcoins. Hopefully, you save yourself or you protect yourself with Bitcoin. Otherwise, I like Argentina because there are tons of Italians there. Like a lot of Italians. So most of the Italians from the south migrated to the US. A lot of people from the north migrated to Argentina. So we have a lot of. It's almost like a second Italy in a sense. But yeah, it's a pity that you have this problem. I don't even know. One day I want to study what happened to Argentina. Why inflation is so bad there? I think it should be. I want to understand it myself. I don't know the history of it. I don't understand what happened. Because you have a lot of. It's a nice country, right? So I don't understand it. Something happened, some bad decision that, of course, the government made, and then it becomes a vicious spiral, right? Instead of Bitcoin being a beautiful spiral, it's a vicious spiral. Anyway, so unless there is some more okay, so let me answer the question, and then we really finish, because Alan asking good questions. But the price was not random; it was from a power law. Well, it's random in the sense that I added a lot of noise, right? So you can see that there is all this randomness. But also I randomize the power. So when I did the movie, and I don't know if you see the video, I did it with one power, another power, but I can add other things. I could make it it doesn't have to be a power law. It can be anything. Okay. I just made it a power law because it looks like Bitcoin. You see that little curve, etc. That is not the point. There is really no relationship, right? There are two different things. Here I'm making this random stuff, and here there is this thing that moves like this, and they are not related to each other, but because I'm plotting one versus the other, they look related, and because they are both processes of time. So in fact, I don't know if I have time for one. Okay, let me show you this slide, right? Maybe this will clarify a little bit more. Maybe it's worth it. Let me see if okay, let me do this, okay? So, and there are other slides. So if that doesn't convince you, this is another slide. For example, this is the difference, right? It's a change. So the difference in issuance. So if it is negative, it means we went down in issuance. If it is positive, it went up, right? And now when you look at it in this way, the jumps are not even there because they disappear, because it's just like another change. You're not giving importance to these silly jumps. And you can see that this quantity is completely symmetric. That is, again, another way of verifying. So because as a scientist, you want to do things in 2, 3, 4, 5 ways. I thought that example was very convincing also because it's basically one of the steps the plan B did to create S2F. It's one of the fundamental steps. So I show you it's an illusion. It's based on an illusion. But then you look at this and say, okay, let me look at the changes. It's completely symmetric. You can see it doesn't matter if a price goes down, if a production becomes smaller, so negative number, if a production becomes bigger, it's not correlated with price. There is no correlation at all. With the exception of maybe these guys, and these guys I told you were before the halving, and these kind of make sense because maybe the circulation supply was small and a change in supply, and that happened during, before the halving. So during these times where it was all due to hashing power going up or down, there was some kind of anomaly here where you see that a reduction in production produced some kind of jump in price. Okay, but it was before the halving, and here, in this example, I did in terms of percentage rates. It's just a blob. So even that anomaly there here at most created, like, because now we have percentage here, it created only a change of about 10%, nothing big. But again, it was before the halving and nothing to do with the halving. So because otherwise a big blob, that means the two are not related at all. I just went through this complicated thing to show you that it looks like there is a correlation there, but it's just an illusion. And then this is what S2F does. And we will have another video explaining why the bubbles are important. Right? There is this article, and our theory is very close, not exactly like they explain it here, but basically I say that is the function of the bubbles is that of creating innovation, and that is exactly very aligned with our position. But we will discuss it in another video. And here I wanted to show you this example. See what happens here. If I make it, imagine you have a coin, it doesn't change price. It's very stable, right? The price is all the time the same. So you see here's the price over time, right? Days from the Genesis block of this crazy coin. And, here it's like never went anywhere because it's like you sell them. I could change any price. I just, whatever, I was like playing with numbers, but here is basically 10 to the minus 7. So you need to sell billions of these coins to get a dollar, hundreds of millions to get a coin, to get a dollar. It doesn't matter what the price is. It's just, something that I made up. But the point is it's stable. It's stable. And the reason it's again, how I constructed is creating a lot of points here, whatever, because it's a kind of a log kind of graph. But you see how stable it is, right? So it's basically because somebody asked me what will happen, because as you start to think about these, you're asking questions for this. Okay, what will happen if this happens? What happen? What if the price goes down? What if the price goes up? So in this case, the price is flat. So what happened in that case? Well, okay, this is how we look like in this chart where I have issuance on the x-axis instead of time, and so it's flat as it should be. And now you see the little clusters are flat also because they don't jump, right? Because the price doesn't jump. But it's not that the cluster are causing anything, because this is exactly, again, I didn't change the issuance of Bitcoin. The issuance of Bitcoin is what we see in the x-axis. But it's flat simply because it's supposed to follow the price wherever the price goes. The question is, because on how you are plotting it, it's an illusion. And the question is, how will it look like if it was a causation? Well, it will look like where, like I say, first of all, during the halving, you will not have absolutely any reason in between the halving that there was no connection between these two things. So you should see these little blobs, instead of being blobs, should be like little, kind of not perfect, but kind of linear. They should be linear. You change issuance, you make the issuance less, it should follow, the price should follow if it was a causation. And all for if some weird reason where during in between the halvings, but it also goes against your theory that the reaction is later. So if there is a reaction later, I should see a jump later. So when I see this, it should not be staying flat. Your theory will be, well, Giovanni, the market responds later. Well, why don't I see a jump here, like a big, huge jump? It basically stays like a blob. So there is no after effect, like what Plan B claims. There is not, right? There is no correlation between these two things. And also, the price, will be not regular like this. So there is something else that drives the price. There is something else that drives the price that is not that is happening all the time. Like you can see here, when that is true, because with Bitcoin, right? You see how a model like that can explain what happens between the bubbles. The price continues to go up. That is the beautiful thing, right? When people say 3 green, 1 red, that is because the price goes up during the bubble, it goes down. That red candle, that red year basically takes 1 year. This is what that meme means. The price for Bitcoin, it goes up during the bubble, it goes down during the bubble, that is 1 year, it takes 1 year, and then it spends 2 years at the bottom, when we call it bear market. That is not a bear market because it follows the power law. So basically we have only 1 year bear and 3 years bull. These are Bitcoin, crazy Bitcoin is. And the reason why we have the bear is because we went so much up that we need to come back to the general trend. And so that model based on issuance or changing the issuance has no way to explain this. Absolutely not. And in the power law instead explains it, because that is actually the general trend, and these other things are a deviation from the trend. See, it's the difference between doing science and telling people bullshit. And I'm sorry if I use this word, but in Italy, we are like that. We are not passive aggressive. We tell you in the face. When we love you, we tell you we love you. When we say you pissed us off, we tell you, vaffanculo. And then maybe we make up and became friends, etc. But we tell you straight, but this is how it is. So, and all the other power laws are there, and they all mean something. They are all causes. There are real causes behind these things. Like another day we can talk about hash rate. Why hash rate? So hash rate, price and hash rates are related by the square root. So basically price equal hash rate. So that means also the hash rate is predictable. Can you imagine the significance for miners that they can plan ahead if they start to study these and we find value? There is scientific validity to this. They can plan ahead with their hash rate and make plans about how much they need to invest, etc. There is a lot of stuff and value in this. Now, scarcity. See, I'm trying to build an entire theory of Bitcoin that doesn't include scarcity. And the main reason, of course, being a science, is because I don't see scarcity. I don't see it anyway. If anybody can come and give me, say, Giovanni, look, this on-chain parameter, because we go all with this on-chain parameter. This on-chain parameter that has to do with scarcity, and this is how it works, and this is what I will be the first one, because it makes me understand Bitcoin better, to say, wow, you're right. The data says that you're right. So philosophy never trumps above science. And if science says that, then I would need to modify my philosophy. But right now, my science says something. I believe in science. I believe in data. There is no place, I don't see anywhere where anything that has to do with scarcity plays a role. And on top of that, there is this entire philosophy. To me, scarcity has to do with Black Friday. And Bitcoin should not be a Black Friday kind of phenomenon. Now, people confuse because, and I will say, we will have another episode where we talk all about these things, about what is the difference between a finite supply, finite cap, that is a fixed cap, or a finite supply when we mine all the Bitcoins. There is that I will never be against it, because it was actually one of the most revolutionary things about this monetary system. But it's a completely different subject. It's a completely different subject that people, for some reason, conflate, mostly because this is what they were taught. And I think the main problem is with Coin Standard, that I would never talk bad about it, because it's one of the best books about Bitcoin, but it needs an update. It needs an update. And I want to give that update, even if it seems arrogant that I'm trying to, but it's a book. It's not the Bible, even the Bible, whatever you beliefs are, whatever, it's not perfect, because we don't use the Bible to, do a, surgery on people, we use science. So, it needs an update. And I think this emphasis on scarcity is the wrong emphasis from a philosophy point of view, from a science point of view, I don't like it. In particular, it doesn't convey the right information about what Bitcoin is and the fact that it has this property like a fixed supply. The fixed supply is all about something different that is very important for Bitcoin, but it doesn't have to do with scarcity. But we can discuss it another time. So this is why one of the reasons why I wanted to break it down in pieces was that many people use this think of a issuance as like kind of an argument for scarcity. Like, this is why, for example, the title of the article from Plan B was Bitcoin model based on scarcity, right? And here I show that the measures that you will associate with scarcity, like this change in issuance, has no predictive power about the price. It doesn't have anything to do with the price. In fact, it's just an illusion, and you are fooling people and fooling yourself by claiming there is such a connection. And so I wanted to break it in pieces because I want to make an argument, say, okay, you cannot use this. Is there anything else? Come up with another measure. Is there any other measure that you can tell me has anything to do with price? Okay, this other measure. Okay, let's look at this other measure. The main measure that people use is this change in flow. In fact, the change in issuance, and I just demonstrated in this long talk that, and it took me all this time, right, to make a case and explain it because I want people to understand it. It has absolutely nothing to do. It's an illusion. It's really bad. It's not even like, maybe so, maybe no. No, it's really garbage, like complete, total, utter garbage. It's actually misleading people. It's horrible. No, it needs, really. Let's break it in piece by piece, okay? The entire point of this talk was to focus on something simple, so it doesn't confuse people. So I want to talk about scarcity as a general concept. I want to focus on one component, and that component is these issuance, because if this is how you also do progress in understanding. You break down in components when you put it all together. So another time we can talk about supply, and then we can see how supply and issuance work together. So come up with any measure that you think has to do with scarcity, and then we can analyze it. This entire talk was about issuance, because it's really what changes, is the only thing that changes. The supply changes as a consequence of the halving, so of the issuance changing. But the real focus on the halvings is the change in this issuance, right? That is really the only thing that changes first, and then of course that changes how much supply we build over time. But it's simply because supply is this rate of production times time, right? So it's a derivate. It's something that is linked through issuance by time. Anyway, now hopefully I made a case. If you still have questions, you can ask the questions in the comments. You can come. We can continue this discussion on X. If you want to join our Discord, we can continue to do that. The finite supply has a role. I'm not trying to say, oh, look, Bitcoin doesn't have a finite supply. It was a bad idea to have a finite. It was a genius idea. But what I'm claiming is that the finite supply that many people confuse, and that is part of my objection to this entire idea of scarcity, is that people confuse finite supply with scarcity. And they really are two different things. And it's not semantics. By the way, semantics, if you go on the dictionary, look what semantics means. It means the science of meaning, okay? It's a science of meaning. I met one of the biggest scholars of semantics in Italy, that is Umberto Eco. I took one of his classes, so I know what semantic is. It's a very important science, a science of meaning, the meaning of words. So it's very important to give a right meaning to words. And so scarcity means certain things that have nothing to do with finite supply, and people confuse. So part of what I'm trying to do, and is the most difficult thing, because people really resist that for whatever reason, because they were taught in that way by the Bitcoin standard, because maybe they have certain ideas in their head. They are afraid that if you start to say that Bitcoin is not scarce, that take away the value of Bitcoin. No, the other way around. Because Bitcoin doesn't need scarcity. This is what I'm trying to say. It doesn't need at all. It has value because it's valuable. This is all. It's not because it's scarce. And we can have this discussion another time because it's a complicated discussion. And my approach right now is I want to break it down in small pieces, and then we absorb one piece at a time. And then when we are ready, we can have a big discussion about scarcity, the philosophy, the history, because it's also interesting to look how people thought about it in time, the different philosophers that discuss about scarcity. It's a very important topic. We can discuss the philosophy, but also the science. Maybe we can build a new vocabulary, new concepts, and maybe little by little we leave away this idea of scarcity, and we can come up with something else that is better, that gives a better message to people, that is more aligned with this idea of abundance, because in the future we are going to have abundance. Okay, I know that some people want war, they want destruction, they want to be, zombie apocalypse. I don't want it, and many people tell me, well, the fact that you don't want it doesn't mean that we don't have it. Well, if we are free agents and we want to, change the world, why don't we do something so it doesn't happen? All of us can contribute, and maybe we avoid the zombie apocalypse. And Bitcoin is a tool for that too. Maybe Bitcoin is going to stabilize the world, and so we don't have the zombie apocalypse. We can still have a revolution, but it's a blood revolution. Nobody dies. Everybody is going to be a better life. Why don't we try that? Then if the zombie apocalypse happens, we will try to do something about that. But I'd rather not to have a zombie apocalypse. Okay, so let's do something not to make it happen. Ciao, Elma Cico, notte fonda qua. Sì, lo so. Scusami. Okay, look, this has been basically 3 hours now. And I was actually joking that we were not going 3 hours, but hopefully it's useful. Maybe people come back to the video, or other people will watch it and can break it in pieces, and maybe my son hopefully can put timestamps. I thank you so much to be here with us, and spend your time listening to me and thinking about this stuff. Continue to follow the channel, continue to follow me on X, and we can learn together. Okay, so I'm really grateful because you helped me also to understand all these things myself. I did more progress when I started to interact with people on X, etc. Even if sometimes people send me some hate or some resistance or some criticism, but I'm doing so much progress, more as a person, but also as a scientist. So all my discoveries are also all your discoveries, and we do this together. Okay, and I really care about you. I give you a big hug, Italian hug, and we see each other soon. Okay, I love you, everybody. Ciao.